आइए स्वागत करते हैं माननीय मुख्य अतिथि महोदय ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया श्री गिरिराज सिंह। एक बार जोरदार तालियां हो जाए, धमाके वाली तालियां। ये खुशकिस्मती हमारी, सौभाग्य हमारा कि हम सभी के बीच ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया श्री गिरिराज सिंह जी यहाँ पधारे हैं, आज चीफ गेस्ट। तो बेसब्री से इंतज़ार हो रहा था उनके आने का। हमारे सारे जितने भी यहाँ पर मेंबर्स हैं सब वेट कर रहे थे और फाइनली हम उनका स्वागत करते हैं। तो ये वाकई बहुत शुभ मौका है हम सभी को सपोर्ट करने के लिए, सभी का साथ निभाने के लिए। माननीय मुख्य अतिथि महोदय हम सभी के बीच पधारे हैं, सभी मेंबर्स का हौसला बढ़ाने के लिए और साथ ही साथ आज के प्रोग्राम को सपोर्ट करने के लिए हम सभी के बीच, हम सभी के चहेते द चीफ गेस्ट ऑफ आवर प्रोग्राम ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया श्री गिरिराज सिंह। एक बार माननीय मुख्य अतिथि महोदय के लिए एक बार जोरदार तालियां हो जाए दिल खोल के। तो मैं मंच पर स्वागत करना चाहूँगी श्री गिरिराज सिंह जी का और साथ ही साथ मैं मंच पर आमंत्रित करना चाहूँगी श्री राजीव सक्सेना जी को, जॉइंट सेक्रेटरी मिनिस्ट्री ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया, मिस रूप राशि टेक्सटाइल कमिश्नर मिनिस्ट्री ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया, श्री विदित जैन चेयरमैन निट्रा काउंसिल ऑफ एडमिनिस्ट्रेशन, श्री संदीप होरा डेप्यूटी चेयरमैन निट्रा, श्री प्रकाश वासुदेवन डॉक्टर प्रकाश वासुदेवन डायरेक्टर सिट्रा, श्री प्रग्नेश शाह डायरेक्टर अटीरा, डॉक्टर टीवी श्री कुमार डायरेक्टर बिट्रा and Dr. Arindam Basu, Director General NITRA. Thank you. Kindly be seated everyone. So a very good morning to all of you present here in this wonderful morning. I, Anchor Simran, welcome you all to the 62nd Joint Technological Conference organized by 4 Textile Research Associations, ATIRA, BITRA, CITRA and NITRA, and supported by Ministry of Textiles, Government of India, hosted by NITRA today and tomorrow. This 2-day event will feature deep discussions on R&D and its industry applications. For the first time, R&D carried out by all 8 TRAs, ATIRA, BITRA, CITRA, NITRA, IJIRA, Mantra, SASMIRA and WRA will be presented at this conference. An exclusive session on technical textiles and an exhibition on both technical and conventional textiles is also included today and tomorrow. We firmly believe that the professionals engaged in textiles, apparel industries, as well as personnel from military and paramilitary forces will be benefited by taking part in this mega conference today and tomorrow. And now it's a time for the much awaited lamp lighting ceremony. मैं निवेदन करूंगी माननीय मुख्य अतिथि महोदय और तमाम जितने भी मंचासीन डिग्निटरीज हैं, कृपया करके आगे बढ़ें और लैंप लाइटिंग सेरेमनी से आज के प्रोग्राम की शुरुआत करें। द्वीप प्रज्वलन कहते हैं सर्वप्रथम इसलिए किया जाता है ताकि तमाम विघ्नों को दूर किया जा सके, तमाम विघ्नों को हरा जा सके और एक ऐसा वातावरण बनाया जा सके जहाँ सिर्फ रोशनी ही रोशनी हो, खुशियाँ ही खुशियाँ हो और जहाँ सिर्फ सकारात्मकता झलके। तो उसी को ध्यान में रखते हुए लैंप लाइटिंग सेरेमनी जो कि शुभ हाथों द्वारा की जा रही है, मैं निवेदन करती हूँ तमाम गणमान्य अतिथियों से हमारे मुख्य अतिथि महोदय श्री गिरिराज सिंह जी, ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया, अपने शुभ हाथों से शुभ शुरुआत करेंगे। जोरदार तालियों का साथ दें कृपया करके। तालियों का साथ देंगे। तो नमन करते हुए एक बार और जोरदार तालियां हो जाएं। बहुत बहुत शुक्रिया। थैंक यू सो मच टू ऑल द डिग्निटरीज। तहे दिल से धन्यवाद है। कृपया करके तमाम डिग्निटरीज अपना अपना स्थान लें। और अब मैं इस कार्यक्रम की शुरुआत में वेलकम एड्रेस के लिए डॉक्टर अरिंदम बासु से निवेदन करूंगी, जो कि हैं निट्रा के डायरेक्टर जनरल। कृपया कर आगे आएँ और हमारे जितने भी यहाँ पर प्यारे प्यारे सी ऑडियंस है उन्हें संबोधित करें। सो द वेलकम एड्रेस बाय डॉक्टर अरिंदम बासु। लाउड अपलॉज प्लीज एवरीवन।
I have a great privilege of welcoming all Sri Giriraj Singh Ji, Honorable Minister of Textiles, Sri Vidit Jain, Chairman NITRA, Madam Rupa Rashi, Sri Rajiv Saxena, Joint Secretary, Sri Sandeep Hoda, and my co-directors. I'm very happy to welcome you all to our Joint Technological Conference. That is in 62nd. Not only that, this year we are having our Golden Jubilee year, so we wanted to make it in a bigger way. And first time in Joint Technological Conference, there will be papers from all 8 textile research associations. Generally, it used to be only for 4 TRS. Now this year, first time, as per the advice of Saxena ji, we have invited all the TRS, so there will be paper from all TRS. I welcome Giriraj Singh ji. Despite his busy schedule, actually I am told that he had some important work also, so he has left that work and came for here. So we are thankful to you, sir, for coming here. And we are thankful to Saxena ji, who is always helping us in NTTM projects and any other technical queries. Our Textile Commissioner, madam, welcome you, madam, who have come from Bombay to attend this seminar. And our chairman, who has come with his busy schedule, but he has come before time to see this function happening properly. Thank you, sir. To our vice chairman, deputy chairman, Sri Hoda ji, I also welcome you. You have also come so far. Thank you very much for coming. Now let us hope that we will have a good session. Thank you.
बहुत बहुत धन्यवाद सर। और अब माननीय मुख्य अतिथि महोदय को सम्मानित करने की बारी आ गई है। तो मैं निवेदन करूंगी श्री विदित जैन जी से, चेयरमैन निट्रा काउंसिल ऑफ एडमिनिस्ट्रेशन। कृपया करके श्री गिरिराज सिंह जी का स्वागत करें, ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया। हम सभी के बीच शॉल पहनाकर स्वागत करेंगे। कृपया करके शॉल मंच पर लेकर आएं। तो ये खुशकिस्मती हमारी कि हमें मौका मिल रहा है माननीय मुख्य अतिथि महोदय का स्वागत करने का और अपने शुभ कदमों से हमारे माननीय मुख्य अतिथि यहाँ पर पधारे हैं, उन्हें शॉल पहनाकर स्वागत करेंगे श्री विदित जैन जी। कृपया करके जोरदार तालियों का साथ देंगे। मैं श्री संदीप होरा जी से निवेदन करती हूँ, डेप्यूटी चेयरमैन निट्रा। अब वो स्वागत करेंगे श्री राजीव सक्सेना जी का, जॉइंट सेक्रेटरी मिनिस्ट्री ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया। शॉल पहनाकर स्वागत करते हुए श्री संदीप होरा जी, जोरदार तालियों का साथ देंगे। और मैं अब निवेदन करती हूँ डॉक्टर अरिंदम बासु से, डायरेक्टर जनरल निट्रा, कृपया करके स्वागत करें शॉल पहनाकर मिस रूप राशि का, टेक्सटाइल कमिश्नर मिनिस्ट्री ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया। एक बार जोरदार तालियां हो जाएं। और अब मैं श्री संदीप होरा जी से निवेदन करती हूँ, डेप्यूटी चेयरमैन निट्रा, कृपया करके हमारी प्यारी ऑडियंस को चंद शब्द कहकर उनका वेलकम करें। एक बार जोरदार तालियां हो जाएं श्री संदीप होरा जी के लिए।
Good morning, Honorable Minister, Srimati Roop Rashi ji, Shri Rajiv Saxena, members of the dais, dignitaries, representatives from the armed forces, representatives from the various TRAs, all the industry partners, our big Nitra clan, the young minds from the college, and ladies and gentlemen. A very, very warm welcome to this day, which hallmarks the 50 years of Nitra's presence in the textile industry. I remember 22 years ago when I got associated with Nitra, where we started and where we are today. We thank the Honorable Ministry and the various organizations who have supported us in reaching this stage today. Nitra today spans its activities into a number of different avenues, which Viditji will be explaining about. I will not take much of your time. I only want everyone to participate today, understand what is happening, be a part of the entire team as we impart education, interaction, and coordination between the various end users, the industry, and the academia. Thank you all once again for making it for this occasion today. Thank you.
थैंक यू सो मच श्री संदीप होरा जी। और अब मैं निवेदन करती हूँ श्री विदित जैन जी से, चेयरमैन निट्रा काउंसिल ऑफ एडमिनिस्ट्रेशन, कृपया करके आगे आएं और TRAs के ऊपर जो रिपोर्ट तैयार की है उनकी एक्टिविटीज़ के ऊपर कृपया करके वो रिपोर्ट हम सभी को सुनाएं। एक बार जोरदार तालियां हो जाए प्लीज़।
Honorable Union Minister of Textiles, Shri Giriraj Singh ji, Joint Secretary, Shri Rajiv Saxena ji, Textile Commissioner, Roop Rashi ji, Deputy Chairman Sandeep Hora ji, Director General Nitra, Directors of Atira, Vitra, etc., delegates, press and other media personnel, I welcome you all to the 62nd Joint Technological Conference. I am happy to present the works done by Nitra, Citra, Vitra and Atira in front of you. Details of the same has been provided in the book of abstract, which will be released by Honorable Minister a little later. These textile research associations' main activities are conducting research and development activities. During last 1 year, Nitra has engaged in 10 R&D projects sponsored by various government agencies. Similarly, BITRA was engaged in 9 and ATIRA and CITRA in 2 each. Some remarkable ones are development of flame retardant nylon 6/6 fiber yarn, development of specialized firefighter suit, design and development of HEPA filter using electrospinning, development of carbon nanotube reinforced acrylic precursors for carbon fiber, development of high productive electrospinning machine, etc. Beside those, each TRAs are engaged in number of in-house projects. Apart from R&D activities, these institutes are engaged in consultancy services for various industries based on various research findings. During this period, NITRA has provided consultancy services to 90 industries, CITRA to 141. ATIRA and BITRA have also provided consultancy services to various units. With the help of the Ministry of Textiles, these textile research associations have set up state-of-the-art laboratories to help the textile and allied industries in quality assurance. Also, they have been recognized as Center of Excellence for various technical textiles. For example, NITRA has been recognized as Center of Excellence for protective textiles, CITRA as Center of Excellence for medical textile, and BITRA and ATIRA as Center of Excellence for geotextiles by the Ministry of Textiles, Government of India. The laboratories of these institutes are all ISO accredited and recognized by Department of Science and Technology, Government of India. Training of manpower is one of the activities of these TRAs. They provide training at different levels, starting from the CEO to the machine operators. During last 1 year, NITRA trained 500 personnel. CITRA trained 630 personnel. ATIRA and BITRA also arranged a number of training programs. These institutes are closely linked with the industry, and most of the developments made by them are transferred to the industry for commercial production. During these 2 days, 26 papers will be presented by all 8 textile research associations. I request the industry members to take advantage of these presentations and try to adopt new technologies as much as possible. Thank you.
थैंक यू सो मच सर. और मैं अब हमारे विशिष्ट अतिथि श्रीमती रूप राशि जी से निवेदन करती हूँ, टेक्सटाइल कमिश्नर, मिनिस्ट्री ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया. कृपया करके आप आगे आएँ और अपने विचार व्यक्त करें. एक बार जोरदार तालियां हो जाए प्लीज़.
आपका शुभ नाम? थैंक यू सिमरत. आदरणीय वस्त्र मंत्री श्री गिरिराज सिंह जी, राजीव सक्सेना जी, हमारे निट्रा, बिट्रा, सिट्रा, अटीरा एज वेल एज बाकी जितने टेक्सटाइल रिसर्च एसोसिएशंस हैं, सबके डायरेक्टर जनरल्स एंड डायरेक्टर, और निट्रा के चेयरमैन, डिप्टी चेयरमैन जी, आई एम वेरी हैप्पी. मुझे बहुत खुशी है कि आज मैं 62nd जॉइंट साइंटिफिक टेक्नोलॉजिकल कॉन्फ्रेंस में यहाँ पे हूँ. सर, मैं एक चीज़ आपके समक्ष रखना चाहती थी कि ये सारे इंस्टीट्यूशंस ने ड्यूरिंग कोविड बहुत अभूतपूर्व काम किया. सिट्रा ने, बिट्रा ने, निट्रा ने, और इन्होंने जितने हमारे इवन मास्क बनाए थे सर, क्योंकि हम लोग भी उनमें से एक तरफ से हम उन्हें उनका साथ ले रहे थे, दूसरी तरफ से हम लोग भी उपभोक्ता थे, क्योंकि सरकार ने काम करना बंद नहीं किया था. तो मेरे को तो निट्रा ने भी काफ़ी सपोर्ट किया और बिट्रा ने भी, कि हमारे लोगों को प्रोटेक्ट करने में डायरेक्टली भी सपोर्ट किया, बिसाइड्स कंट्रीब्यूटिंग टू द इंडस्ट्री. सर, 60th जो 60वीं इनका अधिवेशन था, मैं ये कहना चाहूँगी सर, इन लोगों ने कई जगह हमारी जितनी रिसर्च एसोसिएशंस हैं, उन्होंने बहुत अभूतपूर्व काम भी किया है. ज़रूरत जो मुझे लगती है वो ये है कि वो इंडस्ट्री के साथ उसका पार्टनरशिप होके उतना ही लेवल पे कमर्शलाइजेशन हो। सर जैसे पानी के केस में वाटरलेस डाइंग पे और सॉल्ट विदाउट सॉल्ट डाइंग पे हम लोगों ने 2 साल पहले सिट्रा में भी उन्होंने प्रोडक्ट भी लॉन्च किया। देर आर चैलेंजेस ऑफ सम कैपेक्स, मे बी देर आर सम चैलेंजेस थोड़ा कॉस्टिंग का, बट ये चीज़ें सर हमारी सस्टेनेबिलिटी को डायरेक्टली फीड करती हैं। तो जो चीज़ लैब से हम उसको कमर्शियल लेवल पे ले जा सकें, तो मेरी सबसे ये गुजारिश है कि इस जितने हमारे TRAs ने डिफरेंट लेवल पे सर 46 पेटेंट्स हैं, ये 2 मैंने आपको सूचित किए, बट और बहुत सारा हिमालयन फाइबर्स आपने अभी देखे ही सर। तो हमें चाहिए कि इंडस्ट्री से प्लस स्टेक होल्डर्स से कि वो लोग इसमें पार्टिसिपेट करें और इसको हम सबके सामने लेके आ सकें। सर एक छोटी सी चीज़ जो मुझे बहुत अच्छी लगी सर, हमारे सबसे बड़े उपभोक्ता हमारे जितनी सेना के लोग हैं, सशक्त सेना के, और ये प्रोटेक्टिव टेक्सटाइल का सेंटर है, और वी कैन सी दैट हाउ आवर मटेरियल्स आर बीइंग यूज्ड। एक समन्वय की बात सामने आती है सर। मटेरियल हमें इनके ज्ञान के थ्रू मिलता है, इंडस्ट्री मटेरियल देती है इनके खोज को देख के, और NIFT उसको डिज़ाइन करता है। तो इस तरह से आपके अधीन जो वस्त्र मंत्रालय है वो हमारी जितनी सेना के जितने प्रोटेक्टिव टेक्सटाइल्स में कंट्रीब्यूट कर रहा है, तो सर उसका आपके सामने दिखाई ही दे रहा है सर। एक और इंटरेस्टिंग प्रोजेक्ट है सर, जो कि आई थिंक IIT के साथ सिट्रा भी कर रहा है, कि कोस्ट को कैसे स्ट्रॉन्ग किया जाए, जिसमें सर हम मैन मेड फाइबर को सस्टेनेबिलिटी पे ला सकते हैं। तो इस तरह की सर बहुत सारी चीज़ें जो हो रही हैं। मेरी केवल एक ये गुजारिश है सर, जब मैं पहली बार यहाँ आई थी तो मुझे बताया गया था कि जितनी हमारे वाहन होते हैं उसमें जितना मटेरियल डिफ़ॉल्ट लगता है, जो गाड़ियों की सीट्स पे डिफ़ॉल्ट मटेरियल लगता है, उसकी कुछ कैरेक्टरिस्टिक्स होती हैं विच आर प्रोटेक्टिव, इसलिए उसको कभी कवर नहीं करना चाहिए, उसको कभी चेंज नहीं करना चाहिए। मेरा 2 साल का एक्सपीरियंस है, रादर 2 साल से ज़्यादा का, कि अभी तक जनमानस में और इंडस्ट्री में इस चीज़ को कोई प्रमोट नहीं कर रहा कि हमें जो डिफ़ॉल्ट मटेरियल आता है, जो कंपनी से आता है, उसके ऊपर कवर्स नहीं लगाने चाहिए, उसको चेंज नहीं करना चाहिए, क्योंकि सर उसमें टॉक्सिक फ्यूम्स होती हैं। तो इस तरह का जो हमारा नॉलेज का जनमानस तक पहुंचाने के लिए, और मे बी रेलिवेंट मिनिस्ट्री के थ्रू, सर मैंने कुछ सरफेस ट्रांसपोर्ट से रिलेटेड लोगों से भी बात किया, उन लोगों तक को इस चीज़ का आइडिया नहीं था कि गाड़ी में जो डिफ़ॉल्ट आता है, चाहे टोयोटा दे चाहे मारुति दे, उस कवर को चेंज नहीं करना चाहिए ना। ये चीज़ बहुत सिंपल सी लगती है, बट लोगों को पता नहीं था कि टॉक्सिक फ्यूम्स आर मोर हार्मफुल। तो ये छोटी छोटी चीज़ें हैं जो सर मैं यहाँ समक्ष रखना चाह रही थी अपने अनुभव के हिसाब से। बाकी तो सर जो R&D स्कीम हम लोग चलाते थे, और अब उसका बहुत बड़ा रूप NTTM, उसके बारे में राजीव आप सबको अवगत कराएंगे। मैं एक बार फिर सारे जो हमारे टेक्सटाइल रिसर्च एसोसिएशंस हैं उनको बधाई देना चाहूँगी, और सर आपकी अनुग्रहित हूँ कि हमारे फील्ड के जितने भी लोग हैं आपका आशीर्वाद पाते हैं, आपका ज्ञान से, और सर हम आपके जो भी आपका आशीर्वाद रहेगा उसको आगे लेके जाने के लिए सर हम सभी साथ में हैं। और सर मैं एक फाइबर तक लिमिटेड अपने को नहीं समझती, और ये तो बाकी लोग भी जानते हैं सर। हम लोग चाहते हैं कि समन्वय हो सके, चाहे टेक्नोलॉजी डिपार्टमेंट हैं, चाहे हमारे डिफरेंट फाइबर्स हैं, और यूज़र्स एंड पे। सर नमस्कार, बधाई आप सभी को, नमस्कार।
थैंक यू सो मच श्रीमती रूप राशि जी। और अब मैं निवेदन करूंगी श्री राजीव सक्सेना जी से, जॉइंट सेक्रेटरी मिनिस्ट्री ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया, कृपया करके आगे आएँ और चंद शब्द कहें। एक बार जोरदार तालियां हो जाए प्लीज़।
गुड मॉर्निंग, नमस्कार। माननीय वस्त्र मंत्री जी श्री गिरिराज सिंह जी, मेरी टेक्सटाइल मिनिस्ट्री में कलीग श्रीमती रूप राशि जी, एंड न्यूट्रा के ऑफिस में श्री संदीप होरा जी, विदित जैन जी, और चारों TRAs के डायरेक्टर्स जो मंच पे विराज हैं, और मेंबर्स फ्रॉम द मिलिट्री एंड पैरामिलिट्री फोर्सेस, लेडीज एंड जेंटलमैन। बात करते हैं रिसर्च की। रिसर्च जिसको अनुसंधान भी बोलते हैं या नए प्रयोग, ये हमारे यहाँ हमेशा से रहा है, हमारी सभ्यता में हमेशा से रहा है, लेकिन किसी वजह से हम लोगों ने जिस लेवल पे अनुसंधान करना चाहिए था, रिसर्च करना चाहिए था, वो हमने नहीं किया। सो इसकी इम्पोर्टेंस, रिसर्च की इम्पोर्टेंस अगर आप देखेंगे तो अभी जो फिगर्स आते हैं, द करेंट फिगर सेज कि इंडिया केवल अपनी जीडीपी का 0.64% ही रिसर्च पर स्पेंड करता है, जबकि यूएसए 3.5% एंड चाइना 2.4% रिसर्च पर स्पेंडिंग है उसकी। उसके बावजूद भी जो हमारा मिनिस्कल अमाउंट है 0.64% ऑफ रिसर्च, उसको भी हम लोग इफेक्टिवली यूटिलाइज नहीं कर पा रहे हैं। जैसा मैं मिशन में देख रहा था कि 1000 करोड़ का आउटले है, स्टिल 4 ईयर्स में हम लोग केवल हाफ ऑफ द वे तक पहुँचे हैं। तो रिसर्च की इम्पोर्टेंस इतनी अधिक है कि दिस हैज़ बीन रिकॉग्नाइज्ड बाय आवर ऑनरेबल प्राइम मिनिस्टर एंड ही एडेड वन वर्ड, जय जवान जय किसान जय विज्ञान एंड नाउ जय अनुसंधान। सो यू से दैट कि व्हाट इज़ द इम्पोर्टेंस ऑफ रिसर्च इज, तो रिसर्च इज़ वेरी वेरी इंपॉर्टेंट फॉर अस। और आज इसी बात को, महत्व को समझते हुए हमारे वस्त्र मंत्री जी अपनी महत्वपूर्ण मीटिंग छोड़ करके भी निट्रा के पूर्व निर्धारित कार्यक्रम में सम्मिलित होने के लिए आए कि रिसर्च एक्टिविटीज़ को बढ़ावा दे सकें, रिसर्च को देख सकें। व्हेन यू सी द टेक्सटाइल रिसर्च एसोसिएशंस, they are in name itself textile research association. These are the only bodies which is controlled by industry for conducting the research. Their history is as old as of independent India. The first TRA was set up in Atira by Bikram Sarabhai ji 1947. Since then 4 TRAs were there and another 4 TRAs were added. So somehow they are doing the research. They are very very important from the textile perspective. Government has taken so many initiatives for promotion of technical textiles and other applications in textiles. Number of schemes were laid from time to time, and the biggest scheme was launched in 2022 in the name of National Technical Textile Mission, which is aimed for development of technical textiles in the country because it is considered to be a sunrise sector. So in this scheme, there are the major component of the research which is having 1000 crores. So far, 156 projects, including the machinery development, of value 496 crores have been approved. And NITRA has taken 6 of such projects, and we have seen the progress in 2-3 projects just now. So still around 500 crores outlay is pending. So I request the industry members, if they are present, academicians and TRAs, to work for some meaningful, bigger projects so that the money can be effectively utilized and the applications which we need for different areas can be developed. And to facilitate this, the IPR, intellectual property rights, we have modified. As per the scheme, the research is to be conducted only by the government institutions, maybe DRDO, maybe CSIR, ISRO or IITs, NITs, but private participation in fundamental research was not allowed. Only industry partners are there, but they are the silent partners. So we have modified our guidelines and we have said if industry contributes certain percentage in the research project financially, and in proportion to that we will be giving them exclusive rights for certain years to popularize this project. So this is the time when TRA should work in this 2 days conference with the industry and work out some bigger project with industry's financial contribution as per the new IPRs, so that some bigger projects can be taken up, some new applications can be made available to the country for the overall development. Startups, and another important area is startups. NTTM supports the startup and TRAs are playing active role. We have so far sanctioned 12 startups. All the startups are being approved through some incubators, like NITRA has the incubator, IITs, NITs, and Atal incubation centers are there. Through them, anybody can apply for the startups. The grant of up to 50 lakhs can be given without any royalty and equity. Only 10% contribution from the incubator is to be done in technical textiles specifically. So this is a very important scheme, and other areas in the NTTM where TRAs are playing a very important role is the skilling part. Technical textiles require some sort of specialized skilling. There are numbers are very less. It is not like garmenting that you have to impart skilling in lakhs. It may be few thousands or maybe in some areas few hundreds only. But they have the specific skilling for agro-textiles, specific skilling for the geotextiles, and also for the user industry also, not textiles. Just like geotextiles, skilling is required in construction industry. So we have the guidelines, and few days back we have approved 3 programs, one by Atira and one from IJRA and one from CRRI. So other TRAs can also think of their respective sectors in which they are center of excellence, just like NITRA is in the center of excellence in protected textiles. They can develop some sort of skilling course for the textile manufacturers, for the end users also, at different levels. So we are supporting all these skilling initiatives in the ratio of 2:1. 2/3 contribution from the NTTM and 1/3 from the either student or from the industry. So these are some of the initiatives that we are taking in this promotion of this. And regarding the role of TRAs, last year in BITRA, I have mentioned about कि बाकी चारों TRAs को आप लोग क्यों नहीं इन्वॉल्व करते हैं. हिस्टोरिकली आप 4 ही TRA चले आ रहे हैं. जो जॉइंट टेक्निकल कॉन्फ्रेंस जो आज हो रही है, इसको आप करते हैं. तो आपने चारों को इनवाइट किया है, बट मेरा फिर दोबारा ये आग्रह रहेगा कि उनको बिग ब्रदर स्मॉल ब्रदर ना करते हुए इक्वल लेवल पे ले आइए. उनको भी आप JTC का आपका कोई चार्टर होगा, उसको मॉडिफाई करिए, सो दैट दे विल गेट द इक्वल स्टेटस, और वो लोग भी उतना ही एक्टिवली पार्टिसिपेट करें. जो भी हार्डल्स हैं वो आप रिमूव करें. दैट इज़ माई रिक्वेस्ट फ्रॉम माई साइड. और काउंसिल मेंबर्स जो TRAs के हैं, चेयरमैन एंड ऑल, उनसे भी रिक्वेस्ट है कि वो रिसर्च एक्टिविटीज़ को प्रमोट करें, कि उनका नाम टेक्सटाइल रिसर्च एसोसिएशन है. टेस्टिंग इज़ इम्पॉर्टेंट, दिस इज़ द ब्रेड एंड बटर, रेवेन्यू अर्न करते हैं, बट द नेम research association should not be go in the background. There more and more research projects we needed, meaningful research projects and some bigger research projects. So industry के जो members हैं, जो council members हैं, उनको भी इस पर ध्यान देने की आवश्यकता है. Ultimately industry को ही help करेगा, country के help के लिए है. And we had the fund also. इंडस्ट्री पार्टनरशिप की मैंने बात करी ली. पेटेंट्स भी इंपॉर्टेंट एरिया है. आप लोग पेटेंट्स डेवलप करते हैं, पेटेंट्स को फाइल करिए और ट्राई टू गेट द इंटरनेशनल पेटेंट्स. इंटरनेशनल पेटेंट्स की कॉस्ट काफ़ी हैवी होती है. आप लोग छोटे मोटे पेटेंट तो ले लेते हैं, लेकिन जो मीनिंगफुल पेटेंट्स हैं उसमें कोई हेल्प लगेगी, देन वी आर देयर फॉर टू हेल्प यू. एंड इन द एंड आई से दैट TRAs आर रियली डूइंग अ वेरी गुड जॉब, बिकॉज दे आर द कनेक्ट विद द इंडस्ट्री. They are connected with the industry, because other institutes like IITs, NITs, they are doing the research, but they are doing mainly for the academic purpose. And you are the bodies which are directly controlled by the industries. You can do the really the research that we need. And with this, I wish all the success for this joint technical conference, and wish that the deliberations in 2 days will definitely help in bringing out some important outcomes that will help in policy making also, and for the progress of the textile sector and for the entire country. Thank you very much.
थैंक यू सो मच श्री राजीव सक्सेना जी. और मैं राजीव जी और रूप राशि जी से दिल से धन्यवाद उनको कहना चाहूँगी. आपने अपने विचार, अपने कीमती विचार जो व्यक्त किए, उसके लिए दिल से धन्यवाद. थैंक यू. और अब मैं निवेदन करूँगी माननीय मुख्य अतिथि महोदय, ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया श्री गिरिराज सिंह जी से. कृपया कर आप अपने न सिर्फ विचार व्यक्त करें, बल्कि हमें गाइडेंस दें, हमें सही राह दिखाएं, सही रास्ता दिखाएं. टेक्सटाइल इंडस्ट्री ने बहुत जो तरक्की की है, उड़ान भरी है, वो गिरिराज सिंह जी के पदचिन्हों की वजह से. एक बार जोरदार तालियां हो जाएं.
मैं सर्वप्रथम धन्यवाद देना चाहता हूं जिन लोगों ने कभी नींव रखा हो, चाहे निट्रा, अटीरा, बिट्रा, सिट्रा, मैं उन सबों को सशक्त नमन करता हूं. जब 1947 में खुद विक्रम साराभाई ने की थी अटीरा का, स्वाभाविक है जब मैं इस डिपार्टमेंट में ज्वाइन किया टेक्सटाइल का मतलब जो चमकता दमकता फैशन के कपड़े दिखते हैं वही लोग समझते हैं आम तौर पे। मुझे लोगों ने मजाक भी किया, अब तो आपको फैशन शो में भी जाना पड़ेगा। हम के बिल्कुल जाऊंगा, हरियाणवी मुरेठा बांध के जाऊंगा, लेकिन जाऊंगा। ये टेक्सटाइल एक ऐसा सेक्टर है जहां सियाचिन में हमारे जवान खड़े हैं, उनके लिए भी हम सोचते हैं। जो आप आजकल इसरो का नाम सुनते ही रहते हैं, जिस इसरो में पूरी दुनिया में भारत की ताकत को ले गया है, उस इसरो में भी इसका काम है। यानी डिफेंस से लेकर के सिविल के हर सेक्टर में, और एक एक इंस्टीट्यूट अपने आप में। मैं बहुत अटीरा में गया था जब एमएसएमई में काम कर रहा था, तब मैं गया था। मिश्रा जी उस समय वहाँ काम कर रहे थे। बिट्रा गया, अनिट्रा में खड़ा हूँ, सिट्रा में नहीं गया। सिट्रा, लेकिन ये निट्रा, बिट्रा, टीरा, सिट्रा के अलावे भी इनके और छोटे छोटे हैं इंस्टीट्यूट। अब मैं देखता हूं कि 1949 में श्यामा प्रसाद मुखर्जी ने सिल्क बोर्ड की स्थापना की। मैं जब बेंगलोर गया तो लगा कि आज जो भारत की सिल्क में ताकत है वो सिल्क बोर्ड के कारण है। जब सिल्क बोर्ड की नींव रखा गया होगा उस समय यह एहसास नहीं हुआ होगा। आज एनटीटीएम में नेशनल टेक्सटाइल मिशन के लिए माननीय प्रधानमंत्री नरेंद्र मोदी की सोच, ये सोच, यहाँ कुछ बच्चे आए हुए हैं। मैंने पूछा ये कहाँ के हैं साइंटिस्ट बच्चे? कहा ये होने वाले साइंटिस्ट हैं, ये स्टूडेंट हैं। और स्टूडेंट जब होता है वही आगे चल करके साइंटिस्ट बनता है। मैं बच्चे हैं यहाँ इसलिए मैं कह रहा हूँ। एक बार हम बनारस में बीएचयू, एक बड़ा ऑर्गेनाइजेशन है, यूनिवर्सिटी है, डीम्ड यूनिवर्सिटी। अब बीएचयू में +2 बच्चे जो रीजनल कॉन्क्लेव टाइप का 500 बच्चे जो टॉप करते हैं उस जोन के, उनका कार्यक्रम था। तो कार्यक्रम था तो मैं समापन में गया। मैं बच्चों को केवल कहना चाह रहा हूं जो विद्यार्थी हैं, मैंने बच्चों से पूछा कि बेटे 7 दिन में पूरे फैकल्टी घूम लिए? हाँ घूम लिए। क्या क्या खाए? बताया, वेजिटेबल, मिल्क प्रोडक्ट, मीट प्रोडक्ट। तब मैंने पूछा कौन इसमें आईएएस बनना चाहता है। एक बच्चा भी हाथ नीचे नहीं रखा, सारे बच्चों ने दोनों हाथ उठाया। फिर मैंने आईआईटी पूछा, उसमें भी हाथ उठाया। फिर हमने डॉक्टर के लिए उठाया, हाथ उठवाया, उसमें भी कुछ उठाए कुछ। अंत में मैंने उस समय जो मेरे दिमाग में आया कि एग्रीकल्चर एजी में, वेटनरी साइंस में कौन कौन बच्चे, तो मात्र 15 बच्चे हाथ उठाए, मात्र 15 बच्चे। 500 में केवल 15 बच्चे, यानी 3% हुआ ना, 3% बच्चे। तब मैंने पूछा, अच्छा बेटे तुमने सब कुछ खाया, अब इसमें से मेरा आग्रह है कोई एक दिन, सॉफ्टवेयर का नाम जानते हो, सबने हाथ उठाया, हमके सॉफ्टवेयर का चिप एक दिन खा के रह सकते हो क्या? कौन कौन खाओगे? कोई नहीं हाथ उठाया। जब नहीं उठाया, और उससे भी मजेदार रहा, जब मैंने कहा अच्छा वो 15 बच्चे जो हाथ उठाए थे, डीन यूनिवर्सिटी के डीन को कहा कि डीन साहब आप जरा इन बच्चों का ट्रैक करने के लिए सारा नाम नंबर नोट करें, मुझे दें, मैं जाऊंगा जहां ये एडमिशन लेंगे, क्योंकि टॉपर बच्चे हैं। उसमें से 3-4 बच्चे तो उठा ही नहीं दोबारा। वो डर गया कि कहीं ऐसा नहीं हो कि जबरदस्ती मुझे वेटनरी में या एग्रीकल्चर में एडमिशन हो जाए। आज ये देश हर सेक्टर में हम ऊंचाई पर जाना चाहते हैं, और नरेंद्र मोदी जी को मैं धन्यवाद देना चाहता हूं। कोई ऐसा सेक्टर नहीं है जिस सेक्टर में रिसर्च का काम ना चलता हो। R&D मैं तो सभी इंडस्ट्री से कहता हूं, मैं टेक्सटाइल में हूं, सैकड़ों इंडस्ट्री है गारमेंट बनाता, लेकिन R&D का काम कोई तीसरा करता। आज नेशनल टेक्निकल टेक्सटाइल मिशन को नरेंद्र मोदी जी ने लगभग 1500 करोड़ रुपया, चाहे वो जिस सेक्टर का हो, मैं देख रहा था इन चारों को, अब 1500 करोड़ रुपया अगर रिसर्च में ना रखे होते, क्या आज लाइलॉन 66 के रिसर्च की चर्चा निट्रा में होता क्या? नहीं होता। बिट्रा गए, कार्बन फाइबर, अभी डायरेक्टर बता रहे थे कि मैं एंड टू एंड ले जाने का प्रोग्राम बनाया हूं, भेजा हूं। तो मैं पूछ रहा था बासु साहब से, मैं भुला गया लोगों को, मैं बह गया इधर, सम्मानित तो कर ही नहीं पाया डैश पर बैठे हुए लोगों का। तो मैं पूछ रहा था बासु साहब से, विदित जी को कहा जरा इधर उनको लाइए। मैंने कहा कि ग्लास फाइबर में क्या ये लाइलॉन को कंपोजिट बना करके हम जो रूफ देते हैं, ढलाई करते हैं, सरिया के जगह पर मजबूती दे सकता है? कहीं दे सकता है। आज बिल्डिंग के ऊपर मटेरियल, पहले जमाना था कि गांव में कहते थे जितना छड़ दोगे उतना मजबूत होगा, सरिया जितना डालोगे। अब उसके वेट के अनुसार अब ये नए नए टेक्नोलॉजी आ रहे हैं, उस टेक्नोलॉजी में रिसर्च हो रहा है। शायद टायर में 6-6 पड़ता या भाई लाइलॉन 6-6 होता या प्लेन 6-6 दोनों। ये जो गाड़ियों की टायर देखते उसमें लाइलॉन 6 और 6-6 दोनों के होते। तो आज मैं जो यहाँ बैठे हैं, मैं अपनी बात तो अलग रखूंगा। मैं विदित जैन से और संदीप होरा जी से ये कहूंगा कि आप के ऊपर ज्यादा जिम्मेदारी है। वैसे आप लोग बड़े बड़े बिजनेसमैन हो, लेकिन जिम्मेदारियां भी आपके ऊपर है। इन जिम्मेदारियों को भी संभालें और पूरे कैंपस के छत पे ग्रीन सोलर लगाएं। श्रीमती रूप राशि जी जो टेक्सटाइल कमिश्नर हैं, इनकी भी जिम्मेदारी बनता है। राजीव सक्सेना जी जो देश के अंदर हम अभी टेक्निकल टेक्सटाइल की चर्चा करते हैं, तो मैं जानने के लिए बीच बीच में इनको अपने चैम्बर में बुलाता हूं, फिर ये हमें इंफॉर्मेशन देते। हमारे डायरेक्टर सभी लोग आए हुए हैं। प्रज्ञेश शाह जी हैं, श्री प्रकाशन हैं, श्री डॉक्टर श्री कुमार हैं बिट्रा के, और हमारे अरुणितम बासु साहब डीजी हैं। सब जगह डायरेक्टर हैं, यहाँ डायरेक्टर जनरल हैं। तो डायरेक्टर जनरल का कुछ विशेष वर्क भी आउटपुट आना चाहिए। श्री एम.एस. परमार, एम.एस. परमार की बात जब मैं करता हूं तो नेशनल टेक्निकल टेक्सटाइल मिशन की एडवाइजरी की मीटिंग हो रही थी। उस मीटिंग में मैं चेयर कर रहा था। मेरे बगल में इसरो के स्वामीनाथन थे, नीति आयोग के थे। ये परमार साहब उठे, उन्होंने कहा मैंने एक नॉन ओवन शीट लाया हूं एक नए कॉटन पे, मिल्क बीट कॉटन है ये। तो हम लोग समझे नहीं, देखा, खड़े हुए स्वामीनाथन जी और हम लोगों ने कहा आइए। उसके बाद मैंने इनको चैम्बर में बुलाया। श्री रवि कुमार ये सस्मीरा के हैं, और मैं दो ग्रुप को यहाँ अलग से बुलाया हूँ। एक मैं 3 ग्रुप को, पीएनजी, वेलस्पन और यूनिचेम, क्या कंपनी का, हाँ, पूरे की टीम को बुलाया हूं। वो टीम को मैं बुलाया हूं इसलिए कि अभी जो मैं फील्ड विजिट किया, मिल्क बीड स्पेशली, मिल्क बीड एग फील्ड में किसानों को 2 लाख रुपए कर दे पाएगा कि नहीं, और देगा तो कैसे देगा। मिल्क बीड का उपयोग तो हमने किया, हमने जैकेट पहन रखा था, इन्होंने दी थी बना करके, वो जैकेट में गर्मी आ गई। मैं 1 डिग्री टेम्परेचर पर लद्दाख लेके गया इसकी रजाई, मिल्क बीड कॉटन का, और गेस्ट हाउस में, एलजी के गेस्ट हाउस में मैंने सारे उनके हीटर बंद करा दिया, उनके बड़ी मोटी मोटी रजाई थी वो हटा दिया, और मैंने 1 किलो से कुछ अधिक का होगा, थोड़ा सा 100-200 ग्राम अधिक होगा। देश में जयपुरिया रजाई के नाम से लोग जानते, लेकिन ये रजाई उससे भी हल्की थी, और मैंने उसको रात में ओढ़ने का काम किया। अब ओढ़ने का काम किया तो इतना कंफर्टेबल रहा। आज मैं पूछ रहा था कि इसमें कितने परसेंट मिल्क बीड कॉटन थे, इन्होंने कहा 30%। हमने कहा 30% क्यों दिया? कहा सर अभी सियाचिन के लिए हम जो बनाए हैं उसमें 40 या 50 कुछ दिया है, मिक्स किया है परसेंटेज सिंथेटिक फाइबर के साथ। यानी आने वाले दिन में इसकी इकोनॉमिक्स अगर किसानों के लेवल पर जो हमें उम्मीद है कि निकल आएगा, तो एक नए फाइबर का हम लोगों के बीच में उदय होगा। और नरेंद्र मोदी के आने के पहले हम टेक्निकल टेक्सटाइल को कभी एक्सपोर्ट नहीं करते थे। आज $3 बिलियन का हमने एक्सपोर्ट भी किया है, और उम्मीद कर रहे हैं कि 2030 तक ये कम से कम 5 गुना आगे जाएगा, क्योंकि इसके वर्टिकल बहुत ज्यादा है। कार्बन फाइबर से लेकर के इतने वर्टिकल है, 12 से 15 वर्टिकल है सब मिलाकर के। और ये जब ये सोच अगर किसी में है तो देश के प्रधानमंत्री, कल कुछ एम्बेसडर आए हुए थे मिलने के लिए, उन्होंने पूछा कि प्रधानमंत्री, हमने कहा प्रधानमंत्री जहां हम सोचना बंद करते हैं वहां से प्रधानमंत्री शुरू करते हैं। ये प्रधानमंत्री का सोच है। जब कोरोना काल में सब लोग कोरोना में तबाह थे, जिसकी चर्चा हमारे लोगों ने किया, रूपराशि जी ने मास्क की चर्चा की, केवल मास्क और वैक्सीन ही नहीं बल्कि 1947 में हम बट करके आजाद हुए, 2047 शताब्दी वर्ष हम मनाएंगे। भारत कैसा भारत होगा, हमें क्या क्या चाहिए उस समय तक, इसका भी ब्लूप्रिंट। जब मैं 24 का चुनाव लड़ने जा रहा था, लास्ट कैबिनेट की मीटिंग थी मंत्रिपरिषद की, तो उन्होंने गेटवे ऑफ 2047 की पूरी चित्र खींचा और सभी मंत्रियों से कहा कौन चुनाव लड़ेंगे, कौन चुनाव नहीं लड़ेंगे, कौन जीत के आएंगे, कौन नहीं आएंगे, ये अलग है। सभी सेक्रेटरी से कहा आप अभी से प्लानिंग करो, अगले 3 महीने का क्या क्या हमें काम करना है। अब फिर जब सरकार नई आएगी तो जो तुम बजट बनाओगे वो बजट या रूपरेखा वो होगा 47 का एंट्री पॉइंट। ये समर्पण और ये कॉन्फिडेंस, क्या 47 में मोदी जी रहेंगे, लेकिन देश तो रहेगा। वैसे ये मंच है नहीं। एक नेता ने, अध्यक्ष है एक बड़े पार्टी का, उन्होंने कहा मैं तब तक नहीं मरूंगा जब तक मोदी जी को हटा नहीं लेंगे। तो मैंने कहा तब तो 100 साल आपको जीवित रहना होगा। भीष्म पितामह की तरह आप बांसैया पर पड़े रहिएगा, अब मोदी देश को बढ़ाते रहेंगे। लेकिन आज जब भी किसी चीज की चर्चा होती है, आप अंदाज करें कि आज फूड ग्रेन सारे साइंटिस्टों ने ही दी है। चाहे साइंटिस्ट किसी सेक्टर के हों, ह्यूमन सेक्टर के हों, चाहे एनिमल सेक्टर के हों, इंजीनियरिंग सेक्टर के हों, टेक्सटाइल सेक्टर के हों, हमारे पुरातन काल में ऋषि मुनि साइंटिस्टों का काम करते थे। उन्होंने अनाज दी है, सब कुछ दी है, ये ऋषि मुनियों का दिया हुआ है। उसी तरह साइंटिस्ट भी हमारे नज़र में ऋषि मुनि ही है कि वो कई सालों तक काम करते रहते हैं, तब जाकर के कोई रिजल्ट आता है। तो आज नेशनल टेक्निकल टेक्सटाइल मिशन के तहत जो साइंटिस्ट काम कर रहे हैं, अब हम कार्बन फाइबर का नाम लेते हैं, हमारे पास टेक्नोलॉजी नहीं। आज हमारे साइंटिस्ट उस मुकाम पर पहुंच दरवाजा खोलने की स्थिति में है कि दरवाजा खोल दिया है, दरवाजा खुल गया है। कह रहे हैं दरवाजा में आधा तो देख के आया था, दरवाजा खुला नहीं था अभी तक। दरवाजा हम खोल लेंगे, कार्बन फाइबर भी अब मुझे दूसरे पर मोहताज नहीं होना पड़ेगा। आने वाले 1-2 साल में भारत के अंदर कार्बन फाइबर भी होगा और लाइलॉन 6 भी होगा। ये जब हम आत्मनिर्भर भारत की ओर बढ़ रहे हैं, ये सोच हमारे प्रधानमंत्री का है। मैंने अभी एक स्टार्टअप, हमारी बहन बेटी यहाँ बैठी हुई है साइंटिस्ट, या स्टार्टअप फ्लैक्स पे, हेम्प पे, तो ये हमारे देश की यही ताकत है, हमारी ताकत है और भारत के लोगों की ये क्षमता है। आज देखिए हम कहां चले गए, चांद पर पहली बार जब गए तो किसी ने सोचा नहीं था। हम सूरज के भी चक्कर लगा रहे हैं, हर असंभव काम को संभव करने में देश के हर सेक्टर के लोग लगे हैं। अभी कुछ दिन पहले हम लोगों ने 12 स्टार्टअप को दिया है कि आप जाकर के काम करो। उसमें कई सेक्टर है, टेक्निकल, टेक्सटाइल भी है। निट्रा ने भी एक स्टार्टअप को मंजूरी दी है, अटीरा ने 3 को दी है, बिट्रा ने 2 को दी है, सिट्रा ने 1 को दी है। और मैं समझता हूं कि आने वाले दिन में मोदी जी ने जो 1400-1500 करोड़ दिया है, जब ये आगे फलेगा फूलेगा तो निश्चित रूप से भारत, आत्मनिर्भर भारत, आज इंडस्ट्री को पार्टनर बनाए हैं निट्रा ने, बिट्रा भी बनाया होगा। जब तक इंडस्ट्री नहीं साथ में आएगा तब तक हम उसको ऊंचाई पर नहीं ले जा पाएंगे। अब कुछ लोगों को इंडस्ट्री से प्रेम भी है, इंडस्ट्री को गाली भी देते रहते हैं। हम इंडस्ट्री का उपयोग देश के बिल्डिंग के लिए, देश को चौमुखी विकास के लिए, क्या सरकार सब काम करती है? करना तो पड़ता है। आज हम राफेल बनाने की बात कर रहे हैं, क्या कोई ना कोई तो इंडस्ट्री ही बनाएगी ना। हम पावर जनरेट कर रहे हैं, हम जो भी काम कर रहे हैं, मैं इतना कहूंगा कि आने वाले दिन में हम उन ऊंचाइयों पर जाना चाहते हैं। चुनौतियां हैं हमारे पास। हमें 2 लाइन लिख भी दिया है, जहां राह में जितने कांटे बिखरे होंगे वहां उतने ही मधुर फल फूल निखरे होंगे। क्या ऐसा होता है? क्या यही होता है, यही होता है। आज हम मिल्क बीट को उसी रूप में देख रहे हैं। मिल्क बीट के साथ हमने आज सैनिटरी नैपकिन की एक कंपनी है, जापानीज कंपनी है ना, जापानीज कंपनी है, वो भी आए हैं, पीएनजी वाले भी आए हैं। जो मैंने कहा कि ये मिल्क बीड, हमने इसकी रजाई तो बना ली, हमने इसका जैकेट तो बना लिया, इसका थर्मल पावर हमने चेक कर लिया। अब मेरे मन में है कि सैनिटरी नैपकिन में ये कॉटन से 1.5 गुना अधिक पानी सोखता। क्या इसका सैनिटरी पैड बन सकता है? क्या लाइनर बन सकता है? क्या डायपर बन सकता है? अब ये रिसर्च को इंडस्ट्री ही करेगा। हमारे टेक्निकल टीम के साथ कोई इंडस्ट्री ही होगा। और मेरा उम्मीद है कि जब ये लोग आए हैं R&D की टीम को लेकर के, तो दुनिया की कोई ताकत नहीं। हमने रजाई के लिए वेलस्पन को कहा, भाई गोरों के लिए दुनिया में जो देश है उसके लिए हम यहाँ से एक्सपोर्ट तो करते हैं गारमेंट्स, लेकिन 4 महीने के कपड़े हम एक्सपोर्ट करते हैं। अब उनके लिए 8 महीने का कपड़ा की चिंता करो। उसमें हमें मिल्क बीड एक कोहिनूर की तरह कॉटन में ये मिला है, और मुझे पूरा विश्वास है कि आने वाले दिन में जब इस पर पूरे काम हो जाएंगे, अगले साल तक इसके एग्रीकल्चर आउटपुट भी आ जाएंगे, क्रॉप आउटपुट आ जाएंगे। मेरा मानना है आज जो दुनिया में रसा, ब्राजील, ऑस्ट्रेलिया ये जो कॉटन पैदा कर रहा है 2000 से 2200 केजी प्रति हेक्टर, और ये सीड के साथ है। अब ये 2000 में केवल 35% ही कॉटन निकल के आता है, यानी 2000 में 700 केजी आया, और ये अभी तक जो हमें समझ में आया है ये कम से कम एकड़ में 1000 केजी होगा दूसरे साल से। ये 1000 केजी होगा तो ये स्पेशलाइज कॉटन होगा, स्पेशलाइज कॉटन होगा, सियाचिन के लिए होगा, एक्सपोर्ट के लिए होगा, और फिर किसानों के लिए भी बंजर से बंजर भूमि में हमें $350 बिलियन पर टेक्सटाइल को ले जाना है, मार्केट साइज, और उसमें हमें 20 मिलियन टन 20 मिलियन टन फाइबर चाहिए। वो फाइबर सारे फाइबर मिला के होंगे। टेक्निकल टेक्सटाइल को हम उससे थोड़ा अलग करके रखें। अब उसमें हमें पॉलिस्टर भी चाहिए, सारे सिंथेटिक भी चाहिए, बेस्कोस भी चाहिए, कॉटन भी चाहिए, वुलन भी चाहिए, सिल्क भी चाहिए। हमने एक और फाइबर जो मेरे नज़र में देश और दुनिया में बैम्बू का फाइबर तो बन रहा है, लेकिन पल्प के माध्यम से। अभी इजरा एक इंस्टीट्यूट है, वो भी रिसर्च का, कलकत्ता में जूट का, उसने जूट और बैम्बू को मिला करके जो फाइबर बनाया है विदाउट पल्प। जूट तो जूट है, बैम्बू को अब धीरे धीरे उस पर काम करना पड़ेगा। अभी 30% अगर उससे फाइबर निकल रहा है, कौन ऐसा बैम्बू है जिसमें फाइबर अधिक है, तो उस स्पेसीज को चुना जाएगा। लेकिन आने वाले दिन में हम दूसरे देशों पर, अभी हम 1 लाख टन के लगभग फाइबर बाहर से लाते हैं। एक देश से 50,000, ऑस्ट्रेलिया से केवल कॉटन लेते हैं, वो हो जाता है 60-70 हजार टन। तो हमें आत्मनिर्भर होना है, और मुझे पूरा विश्वास है, मैं बच्चों से कहूँगा IAS बनना आसान है। रूपराशि कहेंगे कि हाँ तक क्यों नहीं बन गए थे जो आप यहाँ। IAS बनना आसान है, लेकिन उससे ज़्यादा कठिन है साइंटिस्ट बनना। क्योंकि साइंटिस्ट बनना और उसको जीवन में कुछ पाना, रिसर्च करना, ये उस साइंटिस्ट से पूछो जो साइंटिस्ट किसी चीज़ में लगा रहता है, और मैं बच्चों से तो कहता हूँ, अब्दुल कलाम आज़ाद और साइंटिस्ट की सपना देखो ऐसा, जो सपना रात में नहीं दिन में तुम्हें चैन से रहने ना दे। ये सपना देखने की जरूरत है, और जब ये सपना देश का हर नागरिक देखना शुरू कर देता है, तो 12 साल में जापान उठ के खड़ा होता है द्वितीय विश्व युद्ध में। भारत अगर 10 साल में एक नई कीर्ति स्थापित कर सकता है, तो भारत का हर नागरिक, हर बच्चे एक नई कीर्तिमान स्थापित कर सकते हैं। केवल कलाम के इन शब्दों को ध्यान रखने की जरूरत है कि सपना देखो लेकिन दिन में सोने न दे, तुम्हें चैन से रहना न दे। बहुत बहुत धन्यवाद सभी इंस्टीट्यूट को। आज ये अच्छी बात है कि चारों मिल करके हर रोटेशन में आप लोग अपना काम स्थापना दिवस के रूप में मनाते हैं। बहुत बहुत धन्यवाद।
बहुत बहुत धन्यवाद माननीय मुख्य अतिथि महोदय, इतने सुंदर विचारों के लिए, इतने उच्च विचारों के लिए, और हम सभी का, खासकर बच्चों का और जितने भी यहाँ पर हमारे सुनने वाले बैठे हैं, जितनी भी ऑडियंस है, सभी का मार्गदर्शन करने के लिए तहे दिल से धन्यवाद। और चलिए एक बार ज़ोरदार तालियां हो जाए। मुझे यकीन है कि हम सभी की नॉलेज में वृद्धि हुई है, हम सभी के ज्ञान में इजाफा हुआ है। श्री गिरिराज सिंह जी को दिल से धन्यवाद है। और अब बारी आ गई है एक ऐसी पुस्तिका का विमोचन करने की जिसके अंदर 26 रिसर्च पेपर्स और 21 पोस्टर्स का एब्स्ट्रैक्ट है। जी हाँ, मैं बात कर रही हूँ 62nd JTC बुक ऑफ एब्स्ट्रैक्ट की। तो मैं निवेदन करूँगी कृपया करके पुस्तिका लाई जाए और माननीय मुख्य अतिथि महोदय और तमाम जितने भी गणमान्य अतिथि मंच पर हैं, मंचासीन तमाम अतिथि गणों से निवेदन करती हूँ और माननीय मुख्य अतिथि महोदय अपने शुभ हाथों से इस पुस्तिका का विमोचन करते हुए एक बार जोरदार तालियों का साथ देंगे। तो ये बहुत ही शानदार पुस्तक है, ज़रूर इसको देखिएगा। जैसे कि मैंने आप सभी को बताया कि जितने रिसर्च पेपर्स आपके हाथ में भी हैं कुछों के, तो 26 रिसर्च पेपर्स का एक कॉम्बिनेशन है, या ये कहा जाए उसका एब्स्ट्रैक्ट। तालियां प्लीज़ जोरदार। और साथ ही 21 पोस्टर्स का एब्स्ट्रैक्ट इसमें नज़र आएगा। बहुत ही शानदार पुस्तक है। बहुत बहुत धन्यवाद माननीय मुख्य अतिथि महोदय और तमाम मंचासीन गणमान्य अतिथियों को दिल से धन्यवाद है। और अब मैं निवेदन करती हूँ, हमारे निट्रा के कुछ एम्प्लॉयज़ हैं, आपको बता दूँ, कहते हैं एम्प्लॉयज़ का मन वहीं लगता है जहाँ उन्हें स्नेह मिलता है, जहाँ उन्हें सपोर्ट मिलता है, जहाँ हर वक्त उनका साथ दिया जाता है। तो ऐसे ही हमारे कुछ एम्प्लॉयज़ हैं जो पिछले 25 सालों से लगातार निट्रा को सर्व कर रहे हैं, अपना साथ दे रहे हैं और अपनी मेहनत के साथ निट्रा को इस मुकाम तक पहुंचाया है। पहले तो उन 25 एम्प्लॉयज़ के लिए ज़ोरदार तालियां हो जाए जो पिछले 25 सालों से निरंतर सेवा में हैं। और मैं उनसे रिक्वेस्ट करूंगी कृपया करके आप स्टेज पर आ जाएं और हमारे माननीय मुख्य अतिथि महोदय श्री गिरिराज सिंह जी से, यानी कि ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स गवर्नमेंट ऑफ इंडिया, और साथ ही जितने मंचासीन गणमान्य अतिथि हैं उनके साथ एक फ़ोटोग्राफ के लिए कृपया करके मंच पर आएँ। एक शानदार ग्रुप फोटोग्राफ होनी चाहिए। आपका जो योगदान है सराहनीय है, पिछले 25 सालों से निरंतर मुस्तैद हैं और साथ निभा रहे हैं। और इनके इस योगदान के लिए आप कैसे योगदान देंगे? तालियों के जरिए। हर मौसम में, गर्मी में, सर्दी में, बरसात में ये साथ थे। और ये कहा जाए हर खुशी में, हर त्योहार में ये साथ थे और ये भी कह सकते हैं कि जब जब वक्त पड़ने पर ज़रूरत पड़ी, अप्स एंड डाउन्स जहाँ लाइफ में भी होते हैं, वर्क प्लेस पे भी होते हैं, उसमें भी हर पल ये साथ थे। तो 25 सालों का ये सुहाना सफ़र एक सिल्वर जुबली सफ़र है, बहुत ही बेहतरीन, बहुत ही शानदार, बहुत ही सराहनीय। तो इस सराहनीय योगदान के लिए तालियां तो बनती हैं ज़ोरदार। और हम यही कामना करेंगे कि ये लोग स्वस्थ रहें और ऐसे ही अब जैसे 25 कंप्लीट हुए ना, तो नेक्स्ट 25 कंप्लीट हो गए, गोल्डन जुबली हो जाएगी ना, सिल्वर जुबली तो हो गई, अब गोल्डन जुबली का इंतज़ार है। तो आप इनकी हेल्थ की भी मंगल कामना करें और हम यही प्रे करेंगे कि ये स्वस्थ रहें और आगे भी ऐसे ही हमारा साथ निभाते रहें जैसे पिछले 25 सालों में इन्होंने हमारा साथ दिया है। वाकई में काबिल तारीफ़ है किसी एम्प्लॉय का दिल से और पूरी जान से किसी संस्था के साथ जुड़ना। तो हम दिल से धन्यवाद करते हैं हमारे तमाम एम्प्लॉयज़ का। और वोट ऑफ थैंक्स के लिए मैं प्रज्ञेश शाह जी से निवेदन करती हूँ, डायरेक्टर अटीरा। मैं निवेदन करती हूँ श्री प्रज्ञेश शाह जी से, डायरेक्टर अटीरा, टू प्लीज़ कम फॉरवर्ड फॉर वोट ऑफ थैंक्स। थैंक यू।
ऑनरेबल मिनिस्टर श्री गिरिराज सिंह जी, मैडम रूप राशि जी, श्री राजीव सक्सेना जी, विदित जैन जी, संदीप जी, my fellow TRA director and colleagues, dignitaries on the dais, dignitaries of the dais, speakers, participants, and scientists and engineers. It's a great honor for me on behalf of ATIRA to extend our sincere thanks at the conclusion of this inaugural session of GTC. First and foremost, I would like to express our deepest gratitude to the Honorable Minister for gracing this occasion as the chief guest. Your insightful words and truly inspiring to us, शायद सबसे ज़्यादा जिसकी ज़रूरत थी, प्रोत्साहन चाहिए टेक्सटाइल इंडस्ट्री में रिसर्चर्स और इंजीनियर्स को काम करने की, और वो आज आपने किया सर। I also thank Shri Rajiv Saxena ji for all the support that he has been giving, all the direction he has been giving all through the implementation of NDTM, और आज भी उन्होंने जिस तरह से TRS को प्रोत्साहित किया और मार्गदर्शन दिया। Madam Roop Rashi ji, as always, comes up with newer and newer ideas for textiles. Thank you very much, madam. I would also like to thank NITRA council members, NITRA Director General, and all the staff members of NITRA for hosting such beautiful event and facilitating the deliberations today. As the technical sessions are about to begin, I wish you all a fruitful and engaging time. I warmly invite, lastly, to the next JTC, the 63rd JTC at ATIRA Ahmedabad. We look forward to welcome you as we continue this important journey of collaboration and innovation. Thank you again, and I wish you all a productive time ahead. Thank you.
बहुत बहुत धन्यवाद श्री प्रज्ञेश शाह जी। और मैं दिल से धन्यवाद अदा करना चाहूँगी हमारे माननीय मुख्य अतिथि महोदय श्री गिरिराज सिंह जी का, ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया, और निवेदन करूंगी कि एग्जीबिशन के इनाग्रेशन के लिए प्रोसीड करें, और साथ ही जितने डिग्नेटरीज हैं डाइस पर उन सब से भी मैं निवेदन करती हूँ, श्री विदित जैन जी, श्रीमती रूप राशि जी, श्री राजीव सक्सेना जी, टू काइंडली प्रोसीड फॉर द इनाग्रेशन ऑफ एग्जीबिशन। तो एक बार तालियां हो जाए, जोरदार तालियों का साथ देते हुए एग्जीबिशन का इनाग्रेशन करने के लिए अब माननीय मुख्य अतिथि महोदय आगे की ओर बढ़ रहे हैं। हम सभी के बीच श्री गिरिराज सिंह जी, ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया। वी आर सो फॉर्चुनेट टू हैव हिम हियर विद अस, स्पेयरिंग हिज वैल्यूएबल टाइम फॉर अस। अपने कीमती वक्त के साथ उन्होंने आज न सिर्फ हमारा साथ दिया बल्कि हमारी सराहना की, हमारे हौसला का भी वर्धन किया, दैट मीन्स हौसला अफजाई की, और हमें किस तरह से प्रेरित किया कि किस तरह से हम और आगे बढ़कर कार्य कर सकते हैं। इम्पोर्टेंस ऑफ IAS एंड साइंटिस्ट ऑल्सो वी गॉट टू नो फ्रॉम हिम। सो हम दिल से धन्यवाद अदा करना चाहेंगे। कृपया करके तालियों के साथ आभार व्यक्त करें, एक बार जोरदार तालियां हो जाएं। और अब एग्जीबिशन की ओर प्रोसीड करते हुए माननीय मुख्य अतिथि महोदय श्री गिरिराज सिंह जी, ऑनरेबल यूनियन मिनिस्टर ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया, along with श्री विदित जैन जी, चेयरमैन निट्रा काउंसिल ऑफ एडमिनिस्ट्रेशन, श्रीमती रूप राशि जी, टेक्सटाइल कमिश्नर, मिनिस्ट्री ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया, श्री राजीव सक्सेना जी, जॉइंट सेक्रेटरी, मिनिस्टर ऑफ टेक्सटाइल्स, गवर्नमेंट ऑफ इंडिया, एंड वी हैव श्री प्रज्ञेश शाह जी, डायरेक्टर अटीरा, डॉक्टर प्रकाश वासुदेवन जी, डायरेक्टर सिट्रा, संदीप होरा जी, डिप्यूटी चेयरमैन निट्रा, and the other dignitaries, Dr. T.V. Sri Kumar ji, Director BITRA, and Dr. Arindam Basu ji, Director General NITRA. So we are so thankful to all of you, proceeding towards the inauguration of the exhibition, followed by high tea. आप सभी से रिक्वेस्ट है, इनाग्रेशन के बाद सारे जितने भी मेहमान जो आज यहाँ पर एकजुट हुए हैं, हाई टी के लिए ज्वाइन करेंगे। थैंक यू।
Hello. May I request all the delegates to be present in the seminar hall immediately after the high tea, because we will be starting the technical session 1. सारे delegates से अनुरोध है कि inauguration के बाद वो सब लोग दोबारा seminar hall में आ जाए, हमारा paper presentation हमें शुरू करना पड़ेगा। So, all the delegates are requested to come back and be in the seminar hall after the high tea is over. Thank you very much. Request all the delegates, presenters to please join the conference. The technical paper session is just about to begin. All delegates कृपया कॉन्फ्रेंस हॉल में आ जाइए, हमारा टेक्निकल सेशन अभी शुरू होने वाला है। टेक्नोलॉजिकल कॉन्फ्रेंस by Honorable Union Minister of Textile, Sri Giriraj Singh, and other dignitaries a little while ago. Now it's time for technical session. So welcome to the first technical session of this 62nd JTC. The first technical session is on conventional textiles, and there are 4 papers to be presented during this session. Now to begin the day's proceedings, may I first request Mr. Anjani Prasad, Managing Director and Vice President, Textile Effects, South Asia, who will be chairing the session. Please join us on the dais, sir. Thank you, sir. Now, ladies and gentlemen, Mr. Anjani Prasad is a well-known figure in the textile fraternity in India and abroad as well, and is a man who hardly needs any introduction. But as a customary ritual, I take this opportunity to introduce him. Our session chair, Mr. Anjani Prasad, is the Managing Director and Vice President of Textile Effects South Asia. He is a seasoned textile expert with experience of over 38 years working with the textile and chemical industry. He began his career at Century Mills and then Bitra with an audit exposure of cost and process optimization and controls before joining Sandoz in 1991. Mr. Prasad rapidly rose from product manager to business head to the head of country for textiles, leather, emulsion and paper division, overseeing over 400 employees at Clariant. From 2010, he managed various global portfolios in Clariant, and after his spin-off at Arcorama, such supply chain, new business development, etc., till 2015, when he relocated to India as MD of Arcoram India, Nepal and Sri Lanka. After Arcoram's merger with Huntsman Textiles Effects in March 2023, he was appointed as VP Textile Effects for the South Asia region, spanning India, Sri Lanka, Bangladesh and Southeast Asia. Mr. Prasad is a BSc Technical and MSc Technical in Textile Chemistry from the Institute of Chemical Technology. He is also a chartered colorist. Mr. Prasad is Director at Indian Technical Textile Association, Management Committee member of Dye Stuffs and Pigments Manufacturers and Indian Specialty Chemicals Manufacturers, Co-Chairperson of ASSOCHAM, National Council of Textile and Technical Textiles, Chairman of Society of Dyers and Colorists, Educational Clarity, in Advisory Board of Wool Research Association and Bombay Textile Research Association, a member of the Editorial Board of Coleridge and Journal of Textile Association, member of BIS Committee, and is also associated with FICCI, CII and Indo-American Chamber of Commerce. Now, I would like to request Mr. R.K. Gaur, Assistant Director NITRA, to come on the dais and greet the session chair with a bouquet of flowers. Thank you, Mr. Gaur. I now request the speakers for this session, Mr. S. Shivakumar from Citra, Mr. N.K. Nagarajan, again from Citra, Mr. Atharvan Deshpande from WRA, Dr. Sheetal Palaskar from Bitra, and Ms. Afreen Begum, also from Bitra, to join the chair on the dais. Please coming, ladies and gentlemen. Big hands for them. Thank you. Ladies and gentlemen, on request of Honorable Chairman Sir, I am quickly going through the CVs of these 5 scientists. The first one is Mr. S. Sivakumar from Citra. He is a postgraduate in textile technology with about 23 years of experience in industry and research. He did his M.Tech textile technology at AC Tech, Anna University, Chennai. He has received gold medals during both his UG and PG degrees from the respective universities. Presently, he is pursuing his part-time PhD at Anna University on sustainable dyeing method for cotton materials. Earlier, he has qualified in GATE with an All India ranking of 17. He has served in various industries such as Premium Mills Private Limited, Salachona Group, Summer India Textiles, etc. Presently, he is working as Principal Scientific Officer and Head of Textiles Chemistry Division at Citra, Coimbatore. His area of specialization is sustainable chemical processing of textiles and effluent treatment. At Citra, he takes care of research projects related to chemical processing and management of other services offered by Citra, such as testing of textiles and allied products, training and consultancy services to textile mills, etc. He has also headed the survey of textile processing units conducted by Citra at various textile clusters in Tamil Nadu, Haryana, UP, and Ghazipur, Bangladesh, and submitted feasibility reports on establishment of textile parks and ETPs at this cluster. He is the co-author of a chapter, Textile and Apparel Manufacturing in India, in the book Technology Vision 2035, brought out by TIFAC DST Government of India. He has been empaneled as a lead and technical assessor by the National Accreditation Board for testing and calibration laboratories for carrying out assessment of conformity assessment bodies as per ISO, IEC, etc. So far, he has conducted more than 100 audits on behalf of NABL. He is a member of TXD 05, TXD 07 and TXD 36 sectional committees of BIS, and recently he has been nominated as the convener for ISOTC 338 working group. A big hand for this gentleman. Ladies and gentlemen, our next scientist is Dr. Sheetal Palaskar from Bitra. She received her PhD Tech in Textiles from Institute of Chemical Technology, Mumbai, and currently working as a senior scientific officer at Bitra. She has traveled internationally to present her research work at international level and also at national level all over India. Her research interests include sustainable processing of textiles, plasma surface modifications, plasma functionalization, nano finishing, functional finishing of textiles, and smart textile. She has published more than 20 research papers in peer-reviewed international SCI and Scopus listed journals and 2 book chapters. She has 3 patents to her kitty. They are and having hands-on experience in textile testing and analytical instrument handling for research purpose. She has worked on 4 government-funded projects as principal investigator. So it was Dr. Sheetal Palaskar for you. Ladies and gentlemen, a big hand. Her co-presenter, again from Bitra, is Ms. Afreen Begum. She is an M.Tech degree in Textile Engineering and Management from National Institute of Technology, Jalandhar. Ms. Afreen has worked as a Quality Management Officer in Printing Department at Kish Export Private Limited for around 3 years. Currently, she is working as Senior Scientific Officer at Bitra in R&D department. She has successfully completed 2 government-funded projects, eco-friendly natural dyeing of cotton and silk using rare earth metal salts as a moderant, and plasma-mediated natural dyeing of khadi cotton and silk. She has published 5 research papers and also presented her work in several conferences. So it was Mr. Afreen Begum. Our next presenter is Mr. N.K. Nagarajan, a postgraduate in textile technology from Anna University, Chennai. Mr. Nagarajan, after working in reputed textile mills for a few years, has joined Citra in the year 2005. He has been mainly involved in consultancy services to member mills during the past 19 years in the areas of productivity improvement, cost control, modernization, manpower planning, techno-economic viability, valuation of merchandise, yarn realization improvement, yarn quality audit, etc. He has undertaken consultancy assignments in more than 100 mills, including foreign assignments in Indonesia. He is currently working in the capacity of head in charge spinning division Citra. He has to his credit over 30 Citra publications and 11 technical papers published in textiles journals. So a big hand for Mr. N.K. Nagarajan from Citra. And finally, we are coming to the youngest researcher in the session 1, and he is Mr. Atharvan Deshpande. He is a senior research fellow in Wool Research Association. Mr. Deshpande has 23 years of experience in research field. Completed his master's degree from VGTI, MTech Textile. In this presentation, Mr. Deshpande will discuss his findings on wool and special wool based denim fabrics. So that's all about the presenters, ladies and gentlemen. Now I request our chairman, sir, to kindly take over and carry on the session. Please come, sir.
Thank you very much, and good afternoon to everyone. I'm more than happy to be back in these kind of institutes because I also started my career from Bitra, and it was in 86 to 90 I was there in the technical service and doing a lot of audits. And this knowledge is so important, for the industry and to apply it going forward. Now, I'm here now to be a chairman and also moderate this session, but I would like to put in some of the very important words which could be helpful for the team here. One of the things which I see is that not too many people from the end user industry is available in this. So it's more maybe internal kind of a meeting. Maybe if this can be put into the external world and to the research institutes which are there in where various companies can be of great help to take your technology forward. Now, one of the biggest problem which I see in research, because at one time in my global company, I was also head of innovation in terms of open innovation topics, and basically someone develops something and then you scale it up and then take it to the another level. So I was also moving around all over the world with best of university and institutes, and I was looking for projects. But unfortunately, we did not get much in those projects which are actually needs of the hour. And I would like to address some of those important elements. The first thing, when you do an innovation, the whole planning in terms of economics is so important, in terms of capex, in terms of ROI, in terms of why a company has to invest in those kind of projects. You do a research has a value, but this value has to then transmit it into commercial elements, which are very critical. So that's one thing which I would say, and most of the companies now around the world, they're getting into some bankruptcy also. The main reason for that is first that the profit is not the reason, the cash is the reason. So if you manage the cash properly, either in capex, in investments, on projects, plant and technology, and the other part is the networking capital. So if you can make this thing proper, and I feel for all the researchers, there has to be a kind of an induction in terms of the commercial elements of it, in terms of how do we scale it up. That's one thing I would like to say. The important other element which you can see around the world, 70% of the global managers in the industry or big corporates will come from AI background. So digitalization is going to be very important, even in research, even in technology, even in manufacturing, selling, or any elements. I was going, last week I was with PwC, this big company, and then even the financials, they can do it so fast with the AI, with all kinds of KPIs. So we need to adopt this. It's getting very fast, and we need to have that element coming in terms of the business. Other thing which I want to highlight is on the whole value chain of textiles. When you look at where are the issues and where we need really research. Fiber, not too many new fibers have actually come up to drive, the end use. So there is definitely a need. I was hearing some bamboo and jute mixture and various other things happening around. But there's a very high need of polymer chemistry to be taken to another level. Why I'm saying polymer? Because globally, when I visited in 2010 in Berlin, one of the biggest 3D printing show, there are thousands of delegates there coming from Googles of the world and all the airline industry, everyone sitting there. So 3D is going to be important. Now 3D, what it needs is polymer and composites. Now, are we doing any big research in this area to drive this kind of a future? So fiber is one part, and fiber also with polymer, the whole world is shifting towards man-made. It's not fully now with cotton anymore. The other problem which was explored, we need to do a bit more of deep dive, that there are also cotton waste which goes into the seawater and coming back into the system. And they say 60-70% is just cotton, not microfibers, not polymers, but also cotton. When you do a knitwear at the yarn stage or yarn processing, you lose 8 to 9 kilos per 100 kilos of yarn, where it goes into the waste stream. Now, do we not have technologies to see that how we can reduce this waste? Now, this waste is too much. We put in so much of energy, and 8% of the value is too good to be managed in terms of financials. So from the yarn, you go to the next stages of sizing and many other areas. Spandex is becoming big now because I feel the fashion, which I see around the world, I manage about 15 countries, is towards spandex and lycra. And these kind of fibers are getting more and more, but they are sensitive to antimicrobials or microbial attacks in the PU side, and their processing is different. I mean, you don't need ironing at the end of the day, because just steam setting is enough. You take a bath, put your clothes even in your bathroom, it will be set. You don't need to iron it. That small steam is enough, that moisture is enough to set a lycra-based products. So it's a different world now, which we are living in. We need to really recognize that part very critically into the fiber, and then also in the forward. Sizing is a big culprit in the waste. Now, we have denim sizing, then you remove it, and then you do a big process of huge water and energy consumption with indigo. Can we not do it together with pigments? Why you need indigo, for example? So there are really groundbreaking things which you can work on to really drive this whole story. The processing industry in India is not there as it was about 20 years back or 30 years back. When I joined this industry about 40 years back, that time it was prime. Now, people were coming to India for processed fabric. Only 5% is now there out of the earlier 18% share of the world. So the processing is becoming the biggest pain point to work out. Now, value addition of the processing, mainly in technical textile, is happening. A lot of research I see is towards that. But we don't have fibers. We don't have those chemicals made here locally. And this has to be worked down in the value chain to reduce the cost. Otherwise, supply chain will kill us. The other aspect of research has to be on the value creation. India can be successful not by mass production, because China is too big to copy that scale. We have to go into niche, we have to go into value creation. So whatever can create the value can give us the better edge. The other important thing which is also to be recognized is the whole angle of sustainability with ESG compliance. I saw in Bitra they did a big workshop for a week or something only on this matter. It's very important to calculate the scope 1, scope 2, scope 3 emissions and all the related things on the waste, either water, solid, liquid or emissions. But the problem is not so serious there, but the problem is in governance. I mean, a lot of people are unaware. I mean, there are 135 laws to run a company. Now, who is complying to that? And these are the things which one has to do it in terms of some work. Social part is there where people are doing CSR and other activities. And a lot of funding into these research institutes can come also from CSR funds. So we as corporates, we have a lot of funds, but we are relying more on the government funds, but you can also get CSR funds in if you are MCA registered for getting CSR part. And CSR is a big part, and I feel R&D has to be put in CSR. Since we are discussing more on innovation today, so those things have to be looked at. The other area of work has to be in certification. So we need to find the best way. I mean, ZDSC, Scope 3 and a lot of things are there. People are not standardized the certification. I was talking that day that in pharmaceutical industry, which has much more complex reactions, they are able to do just an FDA, and the pharmacopoeia or US for European pharmacopoeia, they are able to manage very well. Also the API part. In textiles, we are not able to do that. So, I mean, these are very important elements which I want to say.
We have to wrap up by 1:30.
Okay, okay. So,
list के accordingly आप बुला लीजिए.
ठीक है. So, there's a deadline of 1:30 to be managed. I know that a lot of people would like to have lunch. So, I would then call the first, presenter, Mr. Shiv Kumar, on his topic of dyeing and sizing of yarn meant for handloom weavers and society and in cheese dyeing machine. So I would be more than happy to listen what exactly you developed then. Thank you.
Thank you, Chairperson, and Honorable Chairperson of the session, speakers on the dais and delegates of the dais. A very good afternoon to one and all present here. Can we have the display on the screen for the delegates to see? Yeah, thank you. Basically, this project is dyeing and sizing together in the cheese dyeing machine itself. This project was funded by the Department of Textiles in Tamil Nadu. This is basically meant for the handloom weavers. So we have done this project and completed it recently, and I am going to present you the gist of this project in this here. So introduction, so you all must be knowing how the handloom industry works in India. It is still in the primitive stage, especially when it comes to dyeing and sizing. Right. Okay, sir. Thank you. So the purpose, we will have to understand the purpose of this project to be able to appreciate it, because we know the hang dyeing is becoming more of an artisan-based work. There is a shortage of skilled laborers in the industry, and the dyeing and sizing is done in a primitive way, as also rightly pointed out by our chairperson. Sizing is the biggest culprit when it comes to effluent handling. So the BOD load and COD load will be very high. When it is treated in the decentralized sector, it is let into the effluent stream directly, and it is causing lot of problems to the aquatic living beings also. So that is why it is very important. This project addresses the need to modernize the techniques of doing sizing, dyeing and sizing in the decentralized sector. Basically, we want to mechanize this project, mechanize this work instead of going with the conventional method of doing things. So the objectives of this project is to introduce the cheese dyeing methodology to the handloom weavers in India, to give the pre-dyed cotton yarn, because they don't have to look at having the trouble of dyeing it and sizing it and in small quantities and having the trouble. The societies and the Department of Textiles can take care of this, and they can supply the dyed and sized yarn to them directly. And it is also to improve the yarn quality and maintain consistency in the yarn quality, because in handloom we also know that it is hard to maintain the consistency, and to empower the weavers with the modern techniques, so that this technology doesn't become extinct. Over a period of time, we are afraid this handloom technology or the dyeing technology may become extinct. So we need to modernize this technology, and finally also to evaluate the quality and give them a good quality yarn for the further processing. And also we need to evaluate the feasibility, because with this project when we have taken up, I was wondering whether it will be feasible to do a mechanization of this process, because most of the lots are done in a small quantity. I was wondering, this has been done for decades together by the handloom weavers, and whether we will be able to make a breakthrough in that. But surprisingly, there is a good economic feasibility to this project as well that we have seen. So to give you an introduction about the sizing process in conventional methodology and the present methodology, you can see in the chart. In the conventional methodology, predominantly the yarn is given in the hank form, then it is taken from the cone to hank, the conversion is made, and then the hank is dyed in a cistern dyeing or a vat, this one in a small vat in a conventional manner. Then it is taken for natural drying, and it goes for ball warping, hang to cone, and it goes then ball warping, followed by that sizing in the street. The sizing can be either done along with the dyeing, or it can be done during the just before the weaving process also it can be done. So different societies follow different methodologies in this respect. But in this project we have just slightly modified the methodology. We have tried to do everything in the cheese dyeing package, so that the spinning mills also doesn't have to supply hank yarn. They can supply the yarn in cone form, then it can be wound and converted into soft package, and the dyeing happens in the usual way, and sizing is also done in the same cheese dyeing machine. That is the novelty of this project, and followed by hydro extraction and drying. So these are some experimental works we have done in different phases basically, because it is probably, I would say this is not a controlled study which we could take, because we have to always collaborate with the handloom weavers, with the societies, and get their this one. You always will understand change is very difficult. When you try to change the conventional methodologies followed by the handloom weavers, it is very difficult to change their mindset. So we have traveled along with them for a period of more than 1 to 2 years, and then convinced them for this technology. And yeah, so we have done it in 4 phases basically. In the first phase we have tried with certain recipes of cheese dyeing and sizing, and the results are shown here. We would say the yarn quality results, when we can say, you all understand, during dyeing process also there is an increase in the hairiness, and after that it is sized and then taken for processing. I would say in the phase 1 we could not achieve good results. There was some poor formation of the film and not resulting in a good reduction in this one. But in phase 2 we could reduce the hairiness to some extent, and there is an improvement in the CSP, yarn CSP also, and also in the RKM value, that is the single yarn strength value we could achieve. And in the phase, with regard to the imperfections also, there is a reduction in the phase 2 if you take into consideration. In the phase 2, we have modified the recipe by using thin boiling starches and acrylic binders. So here we could reduce the the imperfections to some extent. However, and we have also performed the performance study at weaving. These yarns were given to the handloom weavers. We have asked them to do the weaving and give their feedback. So most of them were more than 60, I would say. The handloom weavers were more than 60. So it was pleasure to work with them and get to know them. So these are some of the images, and this one what we have done. So in this picture you can see there is a we can see here, I think. In the last image you can see there is a hairiness, increased hairiness. In the phase 1, the shed opening was not proper and we could not get proper results from that. That is why. But however, we could make some sarees out of it. These are some more images from the handloom weaving sector. And we could, the breakages were studied. The number of breakages were around 10, and the difficulties were the weavers told that they were finding it difficult to press the pedal. Shed opening issues were there, and there is more hairiness between heels and reed, and yarn breakages are a little bit minimal when compared to the conventional one, and they could produce about 12 sarees out of the given yarn. And in the phase 2, the hairiness has reduced compared to phase 1, but
Last
still
2 minutes, sir. Last
yes,
2 minutes.
Yes, the breakages were still higher. So we have gone ahead with some of the characterization of the sizing chemicals, and we have modified the technology. We have gone with the film form, increased film breaking strength. We have gone ahead, and the recipes were modified accordingly. And we have also gone to the phase 3. In phase 3, we have done 2 trials, one with the cheese dyeing and sizing methodology, and for the benchmarking purpose, we have used single end sizing process, because there is no benchmark available for handloom weaving and sizing methodology. So that's why we have used the single end sizing technology as a benchmark. So in the recipe 1, we have used the cheese dyeing method, and recipe 2, we have used the single end sizing. You can see here the count was 80s count yarn, and we have used the cheese dyeing machine. The shade was maroon. The MLR, material to liquor ratio, was 1:10, and the sizing chemicals were the blend of synthetic polymers we have used, and it was PVA free basically, because we need to take care of the environmental aspects as well, and viscosity is given here. So here the sizing chemicals were prepared in earlier, and it was supplied to the weavers directly. And in the other alternate method, we have also used the single end sizing process, wherein after dyeing it was taken for single end sizing, then single end warping, and then weaving was done. So comparatively, for this we have used the Rabatex single end sizing machine. So these are the parameters. So here we have used acrylic based polymers. The speed is about 150 meters per minute. And these are the test results. So in single end sizing, obviously you will know that it is like coating of the yarn with sizing chemical. So the strength is obviously much better, and RKM is also better. But in our process also there is an improvement when compared to the conventional.
Can you conclude now? Can you conclude now?
Yeah, just
half a minute.
Give me a minute, sir. I will do it. And yeah. So these are the test results in the phase 3. Phase 3 also, the imperfections also, there is a trend is there. And the more important thing is the size pickup. The size pickup is significantly lesser in our process. We are using only 2.8%, whereas in the single end sizing process it is much higher. Even in the conventional methodology followed by the weavers, it is about 6 to 8% of the size pickup. So there is a reduction in the size pickup also, and the yarn quality is significantly superior compared to the hang dyeing and sizing process of yarn. And the breakages were almost nil in the single end sizing process, and in the recipe 1 it was 5 to 7. And in the phase 4 we have used a different methodology. We have tried to use 2x160 Syro spun yarn, with which we could improve the process further. I will show you the results of it. These are the process parameters, and you can see there is a significant improvement in the CSP, also in the RKM, that is the single yarn strength. And when compared to hank yarn, the imperfections also is big thing we can say. There is a there is a good improvement in the reduction in the imperfections also with a lesser size pickup. In the conventional process of hang dyeing, the size pickup is about 8%, and in our process it is about 2.8%. So these are some of the images of our implementation. So here the breakages were nil. There were no breaks until formation of the full saree. So the weavers appreciated it very much, and they have also done. So these are some of the advantages I will show you. The fastness properties were also better compared to the conventional process, we can say. And there is a reduction of about 1% in the waste. And there is a good cost effectiveness also. There is a reduction of about 32 to 34% reduction in the cost when compared with the conventional process of hang dyeing and sizing. And these are some of the benefits we can say, like it can be used for small size and bigger size, the revised process. Water consumption is lesser, it is a knotless process. More importantly, it is a ZLD process. There is no harm to the environment, we are not letting out anything, and it will take care of these skill requirement for this process, and there is a good reduction in the cost as well. So these are the overall findings, and I will, so these are the findings. I would say we could do this cheese dyeing and sizing process in the same cheese dyeing machine, and it was well appreciated and taken up by the weavers, and we have submitted the report to the Department of Handlooms and Textiles as well. Thank you very much for your
Thank you,
question.
Shiv Kumar. Now, we can have questions later on. I don't want to comment in between. And I will then invite Sheetal and also Afreen for the antimicrobial functional finishing on cotton using plasma technology for biomedical applications. So we have about 8 minutes.
So presentation, please. Presentation. So, good afternoon to everyone, and as instructed by the session chair, I will not take much time, but will quickly start with my presentation. So, it's not working. It's not working. It's not working. So, the topic of my presentation is, I'm really sorry with this. No, sir. So, antimicrobial finishing using plasma technology is the topic. As we all know, the plasma is basically nothing but the fourth state of matter, which has energetic electrons, ion, neutron, protons. And this energetic electrons, ion, neutron, protons is the fourth state of matter, which is called plasma. So plasma can interact with the fabric in various ways. So there are basically 3 ways. एक slide पीछे लीजिए ना. हाँ, so basically there are 3 ways, that is plasma cleaning, plasma surface etching, and plasma polymerization. So for this presentation, the focus is on plasma polymerization. So here we have used various gases for plasma polymerization, various monomers for plasma polymerization, and we have applied the antimicrobial finishing. So that we will discuss which monomers we have used. So basically antimicrobial finishings are being used in a conventional method also, but as we discussed that in the textile conventional method there are various issues like environmental pollutions and use of hazardous chemicals, use of lot of water. So we are trying to make it environmental friendly using plasma technology. So these are some of the benefits of plasma technology, where we can do it in a very dry and clean manner. And as the focus of today's processing is on sustainability, so plasma technology can be definitely a good alternative for the sustainable processing of textile materials. Here we have used polyoxazoline monomers for antimicrobial finishing of textiles, and these monomers are well known for the antimicrobial properties. Also they are cytocompatible, so there is no skin allergy or something like that. So that's why these monomers are very much in demand for antimicrobial finishing. So for this application we have used atmospheric pressure plasma technology, where we have passed the continuously fabric between two electrodes, and then we have used plasma polymerization using various monomers, that is 2-methyloxazoline and 2-ethyloxazoline, and then we have used some hydrophobic coatings on that using HMDSO monomers. For these experiments we have used 100% cotton fabric, and the gas used was helium. We have done the optimization of plasma process parameters. For this we have used various plasma processing parameters like different power, 2 kilowatt and 4 kilowatt, and we have carried out this experiment for various plasma treatment duration to understand the effect of various plasma processing parameters. So these are the characterizations we have carried out for these treated samples, and the results and analysis will be explained by my colleague Afrin Begum. I invite Afrin to continue the presentation.
Good afternoon, everyone. Moving forward, first we did the FTIR spectrum of ethyl oxazoline to see what the functional groups are incorporated in the fabric. And from the result, we can see the nitro-based functional groups are incorporated, that peaks at 1645, which is basically nitro-based functional groups, and the peak at 1840 are the silicon, which impart the hydrophobic nature, are clearly seen within the peak of ethyl oxazoline sample. Similarly, for methyl oxazoline sample, 1645 we seen a peak of amine, which is a nitrogen functional groups, and 1554 it is a nitro compound. These nitrogen based functional groups are mainly responsible for imparting the antibacterial, antimicrobial nature into the fabric. Moving forward to see how the monomer are coated on the fabric, we did the surface morphological study of the sample, and from the SEM result we can see the polymer are well coated on both the samples, that is ethyl oxazoline and methyl oxazolines. Then to check the hydrophobicity of the fabric, we did the contact angle test, and from the result we can see the contact angle are around 130 to 135 degrees Celsius, which is well hydrophobic. And similarly for methyl oxazoline, the results are well hydrophobic. Further, we cannot compromise with the mechanical strength of the fabric. So we conducted the tensile properties, and from the tensile strength we can see that there is a very minimal decrease in the strength of the fabric of the plasma coated monomer samples, which is within the acceptable limits, and the range comes within the error bar. But for 4 kilowatt treated samples, the loss of strength is little higher, but that is also well within the acceptable limits. Moving on, we did the antibacterial activity test of both the samples, ethyloxyzolline and methyloxyzolline. And from the ethyloxyzolline, we can see that the antibacterial reduction are almost all the samples are above 99%. And these are the specimen images of the ethyloxyzolline samples for antibacterial reductions. And from the specimen, we can see that there is a reduction in the bacterial colonies. And this is also antibacterial activity of methyloxyzolline sample. The result of methyloxyzolline sample are slightly lesser than the ethyloxyzolline samples. Though this is the comparative study, as discussed just now, that the methyloxyzolline sample gives a little less antibacterial reduction than the ethyloxyzolline sample. So from here, we can conclude that the ethyloxyzolline can be a best monomer for antibacterial activity. Next, we did the TG analysis of plasma-coated samples, and from the result, we can see that almost all the samples follow the thermal degradation follow the same trend as the untreated one. Only the ethyloxyzolline, the residue found on the ethyloxyzolline, a little bit more, which says that the monomer are well coated on the fabric. The result also confirms the same. So from the whole exercise, we come to the conclusion that plasma-enhanced chemical vapor deposition of 2 polyoxyzolline monomers have been successfully done on cotton fabric to impart the antibacterial properties. The FTI results confirm the presence of functional groups, that is nitro-based functional groups, which is mainly responsible for the antibacterial activities. And from the comparative study, we found that the 2 ethyloxyzolline monomer can give a better result in terms of bacterial reduction at less plasma exposure duration as compared to methyloxyzolline. Thank you, everyone.
No, thank
we
you.
would like to thank the NTTM Ministry of Textile, Government of India for financial support. We will also like to great thanks to our director, Dr. TV Shri Kumar, for giving us the opportunities to present this work. And last but not the least, we would like to thank to NITRA for organizing this conference and giving up the opportunities to present the work. Thank you all.
Thank you to finish in time. I will only request the people from behind who are just standing or distorting, can you just come and sit in the front? A lot of people are standing behind. So that doesn't look good. So I'll thank you very much.
Thank you.
We can have questions later on. Now I'll invite Mr. Nagaraj to present on the effect of trash and microdust accumulation on lattice apron and its influence on yarn quality from Citra.
Good afternoon, one and all present here. Now I am going to talk about the effect of trash and microdust on the compact lattice apron and its effect on yarn quality. Now let us go to the introduction. This is a pneumatic compact system. In the pneumatic compact system, the fibers are condensed via negative pressure generated by this slot, and lattice apron transports the fiber strand to the delivery line. And the microdust evaluation, that is determination of trash and microdust, is very much essential because it directly affects the yarn realization and as well as the net quality of quantity of raw material, and some extent the yarn quality also affected. Now how the microdust evaluation done using MDTA4. In Citra we are having microdust trash analyzer. In this trash analyzer we are having the microdust, that is we are collecting the trash into 3 different parts, that is a trash and as well as fiber fragment as well as microdust, and we are collecting the sliver in this form. And this is the compact lattice apron. Now we are seeing the cleaned lattice apron in the figure 1 and the partially choked lattice apron and completely choked lattice apron in the last side. And parameters influencing the microdust accumulation. Normally, in lattice apron, number of holes per square centimeter and filament properties of that apron, weave structure and life of apron will contribute the microdust accumulation, and also the count of yarn process. Whether you are processing the coarser count or finer count, accordingly the microdust accumulation will be there, and microdust level of the processed cotton and cotton stickiness properties and condition of humidification plant as well as suction pressure of the compact system and how the cleaning method we are adopting in the suction tube. And the objective of the study is to evaluate the microdust level in the cleaned raw material, and second objective is to study the effect of trash and microdust accumulation in the compact lattice apron and its influence on compact yarn quality, and to study the effect of life of apron on the yarn quality. And these are all the experimental work. The fiber and yarn property measurements. Fiber properties were evaluated using Office Pro 2, and trash evaluation was done using MDTA4, and evenness were measured using Worcester Evenness Tester UT6, and tensile properties were measured using Worcester TensoJet for weaving yarn, and Worcester Tenso Rapid for hosiery yarn, and hairiness were evaluated using Zweigel hairiness tester, and Classimet was evaluated using Worcester Classimet 5. And we have taken the studies in the three mills, Mill A, Mill B, Mill C. In Mill A, we processed 34 combed hosiery and 40 scalded hosiery from the same raw material. And in the Mill B, we processed the 40 scalded warp and 40 combed warp from the same raw material. And Mill C, we processed the 34 combed hosiery. And these are all the fiber quality and microdust evaluation. You can see here that the fiber quality in 34 combed hosiery, the microdust level is 0.0348, and 40 scalded hosiery 0.0504, and 40 combed warp it is 0.0241, and 40 scalded warp it is 0.0521, and C mill 34 combed hosiery 0.0364. This is the compact suction pressure level maintained during that period. And the method of sample collection, we selected the sample cops, that is 8 cops in 6 places, R1, R2, R3 and L1, L2, L3, and we have collected the cops before and after lattice apron cleaning, that is 7 days frequency we adopted, and we note down the lattice apron weight and suction pressure before and after cleaning, and we tested the evenness, hairiness, tensile properties and Classimet to all the samples. And these are the results and discussion. Now let us come to Mill A. After cleaning, we can observe that there is total imperfection in 34 combed hosiery. There is no change, that much change difference in the 34 combed hosiery, but we have observed the difference in thick places and neps in 40 scalded hosiery. And also in the total sensitivity IPA, then here also we observed the same changes. Only 40 scalded hosiery we observed the changes in the IPA sensitivity, and in Mill B, that is 40 combed warp and corded warp, we observed that there is no that much reduction observed in before cleaning and after cleaning. And here also same trend. And but in Mill A, the hairiness reduction, we have observed that in S3 hairiness level also and S3 Zweigel hairiness also, we observed the reduction after cleaning the lattice apron. The combed hosiery also, corded hosiery also. And in Mill B also same trend we observed. In the hairiness level, the reduction was observed. And in the yarn diameter, we measured using UT6, we observed there is a reduction in yarn diameter after cleaning the lattice apron in 34 combed hosiery as well as 40 scalded hosiery and 40 scalded warp except the 40 combed warp. And online Classimet falls also we observed that there is a reduction in Classimet falls, that is thick falls and thin falls and objectionable falls in except 34 combed hosiery, all the Mill A and Mill B, all the there is a changes we observed. And COP Classimet also we observed the same thing in all the except 34 combed hosiery. In all the remaining counts there is a changes in objectionable falls, thick falls and thin falls. And we studied the effect of compact apron life, that is 2 months period, 5 months and 9 months in the Mill C, that is we processed 34 combed hosiery. Here we observed that is total IPA, there is no changes in the total IPA, but extra sensitive IPA also there is no change. But hairiness level, the changes in the 2 months period, lifespan and 5 months period and 9 months period, there is a change in the hairiness value and S3 value. You can see here in the graph also. And on online classmate falls also, we observed that there is a change in 5 months period and 9 months period, that life changes. The short thick falls and long thin falls, and long thin falls also changes. And these are the summary of the findings. No change in apron weight and suction pressure we observed, and reduction in online classmate falls except 34 squam dose area on we observed, and reduction is S3 value after cleaning the lattice apron, and no difference in yarn evenness and tensile properties except 40 corded area, and reduction in yarn diameter and increase in packing density in the corded process we observed, and increase in S3 values and increase in all the fault types as lifespan of the compact apron extended from 2 months to 5 and 9 months. Thank you.
Thank you very much. Now I'll invite the next innovator from WRA, Mr. Deshpande. In the meantime, please keep your questions ready.
Still not displaying. It is. नीचे करना था वो नहीं नेक्स्ट कहाँ है नेक्स्ट ही तो है ये ऐसे नेक्स्ट ही करना है यहाँ पे थोड़ा सा कहाँ पे नेक्स्ट नेक्स्ट चाहिए ये नहीं है मेरा आपका अलग है यार इनको पता है मेरा Very good afternoon to everyone. I will going to present on fabrication and characterization of stretchable and non-stretchable wool blended denim fabric. So if you go in the, it's not going. It is slide is not changing. If you found the history of denim. In 18th century, it is French city called Nimans, which assumed to be the source of denim. It's called Serge de Nimans. It is basically concept is that for denim it is hardware clothing. So the persons who are working on ships or for hard working, they manufactured this denim fabric. It's known for its strength and longevity. If you go with repeated washing and wear, it will become softer and more comfortable. And it is also available in various weights and styles like bull denim, distress, stretch. There are different applications from casual to formal wear. If we talk why wool in denim, blending with wool can improve the comfort, fit and freedom of movement due to its alpha keratin structure, And second one is the increased functionality. If you talk about the wool, it is inherently thermal resistance, so it can improve the thermal properties and enhance this ability to shield from UV rays. Next one, if you talk about advanced moisture management, even in case of wet, Indian wool get wet, it feels more comfortable than cotton. Next one is about odor resistance. Indian wool is already almost odor resistance. And it's next talk about the potential to export. Just Minister said that we order millions of tons yarn from source from import. So why what we focus on Indian wool? So using Indian wool is also one beneficial for export. Next one, objectives are to produce wool denim fabric using blend Indian wool blends and special wool fibers like Angora, yak, camel, pashmina. Next one is to characterize the properties of developed denim fabrics, and third one is to evaluate the performance of denim fabrics. This is the typical flow chart of denim manufacturing: spinning, warping, rope dyeing, sizing, weaving, finishing and inspection. Actually, it's ongoing work, so we developed Indian wool and special wool fabrics in two categories: development of non-stretchable denim fabric. In this, we developed 100% wool based, pashmina based, camel and angora based denim fabric. Next one, we developed stretchable, 100% wool based stretchable denim fabric. So these are the construction parameters of developed denim fabric. We coded as a L1 to L6, first to represent the stretchable denim, and L through to L6 are special wool, non-stretchable denim fabrics. So these are the construction parameter details, and it's ranging almost around 200 GSM. Next one is, this is a view structure we used for our denim fabric. We tested, these are the testings we done for our wool denim fabric: tensile, abrasion, tearing, air permeability, thermal resistance, breathability, drape percentage, handle properties, vertical wigging and dimensional stability. So what we observed in tensile strength, that L1 and L2 which are stretchable, and L5 which is Angora based denim fabric, we observed good tensile strength in case both for elongation and tensile strength. If you compared with the cotton based denims, its warp strength and web strength is for wool is almost more than traditional denim fabric. So this is the abrasion resistance. We tested it for 25,000 rub cycles. What we observed that the L1, which is stretchable denim, it stands out and it shows the minimum mass loss among all. And if you talk about the cotton based, compared with the cotton based denim, its average mass loss is around 0.29 milligrams. So if you talk about tearing strength, if you see the graph, it is showing that L5, which is wool Angora, is showing highest tearing strength among all other warp and weft. If same thing, if you compare this wool denim with the cotton, its average tearing strength is around 26 Newton. So this is a depth percentage we tested for this wool denim. So we found L5, which is wool Angora, its lowest one, showing the softest, smoothest fabric, and L1 is L2 are showing highest percentage, which we can go for suits or suit wool denim suits. We can prefer that L1 and LW for suits. Next one, we tested thermal resistance. Actually, we represented by CLO value, which reflects the clothing insulation, how effectively clothing keeps wearer warmer. So what we found, LW2 is showing highest CLO value. Same thing, if we average CLO value for cotton based denim is around 0.18. So these are the results. The next one is air permeability. So average CFM value, cubic force per meter value for cotton based denim is around 44. And same thing, if we talk about the wool denim, LW3 and LW6, which is pashmina and camel. So it's showing highest CFM values. So it is, we can prefer for lightweight applications of denim, shirts, we can say. This is a breathability test we carried out. From graph, we can see LW1, which is a stretchable, LW4, it is a Angora, and LW6 is camel, which showing good air permeability across all fabric. And average, if we compared with the cotton based denim, it is around 195 gram per meter per day. So these are bending length, bending modulus and flexure rigidity calculated. You can see the LW1 and LW2 flexure rigidity, which is showing the highest value, 558 and 440. So which are less susceptible for deformation under load. So where we can go for where stiffness is required or heavy weight fabric desired.
In case all wave direction we used a wool, so it's showing good less flexure rigidity, which is more susceptible to smoothness. So this is a fabric handle and rated properties we tested: thickness, compression, work, thermal conductivity, total hand and total touch value. So as a you can see total hand value and total touch value, it is around 3. One is for a poor hand value and fifth one is the best one. So it is moderate, all fabrics giving moderate hand and touch values. Overall, we can see LW and LW2 are better for better application for requiring less thickness and lightweight fabric and thermal management. Next one is a vertical wicking. Sorry? I cannot hear you.
You should conclude.
Okay. I will complete. So this is a vertical wicking, and LW stands out from all along, giving highest weft wicking. Next one is dimensional stability. LW2 showing the no dimensional change, and LW5, LW6 showing highest one. So these are the finishes applied after manufacturing our Acroma Leucoprate for breathable finish, and this is the recipe we used, and this is a water repellent finish, Zelen R3, and these are recipe details. So we are tested for this UV protection, drying rate, water resistance and breathability. They are all showing almost good results. So the summary is that we can emphasize the benefits of incorporating special wool yarns into weft as a denim, and it's not only result lighter and more durable fabric, but also offers improved thermal resistance and breathability. Thank you, sir.
Thank you very much. I saw this 4 presentations, and 2 were more on the sustainable area. 1 was in the standardization area, and a new idea coming from him. So there were 4 different elements to it, and I would now invite some questions. If you have anything to ask to the speakers. So all are waiting for lunch, huh? Okay, so during the lunch, okay, there's one, Dr. Som, huh?
This is for the wool denim project of trouser and jacketing. What was the actually blend? Blend means, is it a intimate blend or by arrangement?
So pardon, sir. Pardon.
What was the construction? Intimate blend or by arrangement? Warp, cotton and wave tool?
I'm not getting
Fabric, fabric construction I am asking. Whether it is an intimate blend or it is by arrangement, and what was the GSM?
GSM around 200. Lightweight fabric. Lightweight denim.
Lightweight denim. And then this is for jacket, that for trouser, same GSM?
No, sir. Jacket for higher, 400 around, 450.
And till it is lower compared to denim fabric. What was the arrangement? Is it the warp 100% cotton weft wool?
100% warp, and in weft we use 70% Indian wool and 30% special wool, yak, camel, pashmina.
No, wool is an intimate blend with pashmina. I am asking whether the warp itself, you have done intimate blend of cotton, wool, pashmina, or cotton separate wool and pashmina?
In warp direction, we only use 100% cotton, and in weft direction, we use the blend Indian wool and yak, 70% Indian wool and 30% pashmina, camel.
What was the count of warp cotton count?
Cotton count 2 by 42.
2 by 42 NM, you are telling?
NM, all in NM.
And then it is single count or double yarn?
Double yarn. 2 by 42.
And in weft, what count and what TPI you have done, taken?
42.
Same 42. And TPI?
TPI around 10 to 11.
10 to 11. Okay, thank you.
So if anything is there, you can still continue to, discuss during the lunchtime. I just want to make just one or two statements and then we can conclude. First thing is I thank everyone on the dais and speakers to contribute. They have done a lot of work. I know that we are pushing them to 7 minutes or 8 minutes to speak and to conclude. But I am sure there's a lot of work gone behind. And some of these projects I can see on the sustainable area has some relevance to go to the industry. Now, other important thing is that to really pitch it to the industry, there's a need maybe between these institutes to open up a portal where you have put in this kind of a booklet, but that's more internal. If you put it online, portal, that these are the ideas or technologies which are available for licensing. So the people who would be interested, they can Google it around the world and see these technologies which you have anywhere abstract available, and there's an interest, they can still go for licensing or buying this. This portal is very important. I've seen global portals like Open Innovation Topics, which are very well done. I was talking to the Government of India also to open up a portal, but I feel you all can make a beginning between the institutes to put it all together so that it can be helpful for the industry. Thank you very much, and thank you for the patient hearing.
Hello.
Just before the lunch.
Sir, hello. Excuse me, sir. I just want to clarify regarding compact spinning. What is ordinary dia, without compact and after compact, how much yarn dia effective?
Sir, what's that? Please.
Sir, I just want to clarify, before compact and after compact, how much yarn dia is effective?
Sir, before compact.
Before and after, how much yarn dia effective? It's less or higher?
Sir,
Increased or less?
Sir, yarn diameter, we have not conducted that study, sir.
Okay.
Difference between the compact and non-compact you are asking.
It's the same, before compact and after compact.
Sir, these trials we have conducted in compact only, sir. Compact, lattice apron only, that before cleaning and after cleaning we did, sir.
Okay. Thank you, sir.
Okay, then we can conclude now. Thank you very much.
Thank you very much, session chair, sir, for conducting the session so nicely, and the learned speakers for presenting their papers in such a lively manner. I now request session chairman, sir, to felicitate the speakers with 60-second JTC memento. Let me call the names of distinguished speakers. Mr. S. Shivakumar, please come in, sir. Thank you, sir. Dr. Sheetal Palaskar. Thank you, a big hand for her. Now, from Vitra, Ms. Afrin Begum, please. Thank you. Mr. N.K. Nagarajan. And finally, Mr. Atharvan Deshpande. Thank you, sir. Now I request, ladies and gentlemen, my colleague, Mr. Sanjeev Shukla, Assistant Director NITRA, to join us on the dais and honor the session chair, sir, with the 60-second JTC memento. Mr. Sanjeev Shukla, please. Thank you, ladies and gentlemen, for this wonderful technical session 1. Now, on behalf of Chairman and Director General Sirs, NITRA, we invite you all to join us for lunch. We will be back for continuation of paper. We will be back for continuation of paper presentation in session 2 exactly at 2:30 p.m. exactly at 2:30. So please join the lunch and we will be starting at 2:30 again. Now one very important information, a parallel session for presentation of papers will be running post lunch. So please note that the first session is on protective textiles and that will be held here in the main hall. The other session is on agro textiles and that will take place in the ground floor conference hall inside NITRA building. So we once more remind all our guests and delegates to reassemble in this hall exactly at 2:30 and the parallel hall as well. Thank you very much. Enjoy your lunch.
बैठे हुए शेष
बैठे हुए शेष
तुम बोलो सेशन चेयर को बुला लो
बुलाऊं? वो विजय हैं, उनके साथ बात करें। A very good afternoon. This is M.K. Bansal, Senior Scientific Officer, NITRA, welcoming you, ladies and gentlemen. I am sure everyone is now geared up for second technical session of the day after lunch. The second technical session is on protective textiles. And there are 4 papers to be presented during this session. So, without wasting any time, let us set the roll bowling. To chair this session of the conference, it is my pleasure to invite Mr. Sandeep Hora. May I request Mr. Sandeep Hora to take his seat on the dais, please. Thank you, sir. Mr. Sandeep Hora is a well-known figure in the textile fraternity in India and abroad and is a man who hardly needs an introduction. But as a customary ritual, I take this opportunity to introduce him. Mr. Sandeep Hora is a gold medalist from 4A School of Management and the awardee of prestigious Sampath Kumar Memorial Award for All-Round Excellence from Manipal Institute of Technology. He has spent large part of his growing years with close proximity to the defense services as he hailed from a defense background. His quest for knowledge and excellence has been the catalyst for innovation, research and development of a number of advanced technical textile protective gear for the Indian Armed Forces. This first generation entrepreneur has long-term association with global knowledge-based companies with keen interest in technical textiles. Being patriot at heart and driven by a strong passion of indigenize have been the key attributes towards the focused approach of his company, Messrs. Aranov Industrial Safety Appliances. His company, Aranov Industrial Safety Appliances, closely follows its motto of protecting the protectors. Apart from being vice chairman of NITRA Council, he is also part of advisory boards, BIS committee, and oversees fabric
associations. May I now request Ms. Neha Kapil, PSO Nitra. May I now request Ms. Neha Kapil, PSO Nitra, to honor Mr. Sandeep Hora with a bouquet. Thank you, Ms. Neha. I now request all the speakers for this session to join the chair on the dais. Dr. M.S. Parmar from NITRA, Ms. Shreyansi Nandi from BITRA, Mr. Sashikant Patil from Atira, and Mr. Swami Sharan from NITRA. I would now request Mr. Sandeep Hora to begin the proceedings.
Good afternoon, everybody. Welcome back after, I hope, a good lunch. And with our stomachs full, we can move forward. First of all, being part of NITRA Council, I extend a warm welcome to everybody here in the audience and also the esteemed members of the dais for taking out their time and also giving us their views, which are going to be put forward to the audience. We all know, with respect to protective textiles, it's simply put how we are going to protect a living being, and what comes and becomes a barrier between forces of nature or otherwise. Important thing to note in this word is protective textiles. It's for protection. And everything that is made and developed is keeping the end user in mind. If the industry focuses on that, the sky is the limit. In India, protective textiles has taken off in a big way. We have great impetus from the government of India. NITRA is Center of Excellence for Protective Textiles, especially in the flame-resistant area. And I can proudly say that leaps and bounds is what it's moving in. Our discussion today consists of 4 topics. The first one being optimization of various layers of specialized firefighter suits. That's from NITRA. Flame-retardant cotton fabrics by plasma-assisted chemical treatment. That is from Mrs. Shreyasi Nandi, I'm sorry if I'm not pronouncing it correctly. Then we have behavioral mechanism of composites under high radiant heat from Atira, and development of extreme cold climate clothing from cellulosic base, high flow value, low density natural fibers, which even our minister spoke about, from NITRA. So without wasting any time, let's start with the first panel speaker's presentation / discussion. She will start first? Okay. So we are starting with BITRA first. That's flame retardant cotton fabric for plasma assisted chemical treatment. I invite Mr. Nandi to kindly come forward.
Hello. A very good afternoon to everyone. My research topic is flame retardant cotton fabrics by plasma assisted chemical treatment. As we all know that flame retardant textile is now very much crucial for us because in everywhere, home, household wear and public places, everywhere fire is a means fire plays a very important role, because nowadays we know lot of accidents are happening because of fire. So flame retardant textiles, there is a huge need for flame retardant textiles. Why cotton flame retardancy is important? Cotton fabric is highly inflammable in nature. Cotton, when you put the heat, it will still burn after you removing the source of the heat, and it burns completely vigorously. So that cotton fabric need to be flame retardant is very important. How to make cotton fabric flame retardant? Several literature surveys we have done. Recently, Cheng et al. Reported a novel NP flame retardant ammonium salt of 1,3-diaminopropene tetramethylene dimethylene triphosphonate phosphonic acid. This gives the limiting oxygen index 48.0, but this is formaldehyde based finishing. So nowadays we know that formaldehyde based finishing is banned due to its carcinogenic nature. And in another report, a novel efficient and durable glycerol based reactive flame retardant ammonium triphosphoric acid glycerol ester was synthesis by Guo et al. The limiting oxygen index of the cotton fabric treated with 20% ammonium triphosphoric acid glycerol ester, which gives the LY 37.3, and told that 26.5 after 50 laundry cycle. But we have tried to repeat this. It didn't repeat it, and it is not, and we found that the data is not efficient also. Our approach, what is our approach? Our approach is to treat cotton fabric with a commercially available phosphorus based flame retardant agent, that is 3-HPP, which is very much conveniently using for polyester. Because 3-HPP has phosphorus, both having hydroxyl and carboxylic group in 3-HPP. So we treated cotton with 3-HPP along with BTCA in presence of esterification catalyst, expecting the esterification of 3-HPP with cotton functional group. This may be the probable mechanism that cotton fabric treated with 3-HPP along with BTCA in presence of esterification catalyst, that is DCDA, and we have found that phosphorus incorporated onto the cotton fabric surface, and it gives the flame retardant cotton. This limiting oxygen index, we can see that the limiting oxygen index of cotton is 17.4, and in case of cotton the phosphorus content is 0, and VTR, which is treated cotton along with 3-HPP BTCA and the esterification catalyst, we get the LOI of 30, and phosphorus content we can see that 1820 ppm. And VTR P10, we have done a novel method, that is post plasma treatment we have done. After treating the cotton fabric with 3-HPP BTCA and esterification catalyst, we have passed the cotton fabric 10 post plasma treatment we have given, and after that we have found that the LOI is 31.5 and phosphorus content is also 18.15 ppm. It is quite good. Vertical flammability we have also done. For virgin cotton, we have seen that cotton burns completely within 12 seconds. But in case of treated cotton, we saw that no after flame is there, no afterglow is there, and damage length is 11 centimeter. And in case of when we pass through post plasma treatment, the damage length reduces again, and also there is no after flame and no afterglow. Surface morphology we have checked, that in case of virgin cotton we have seen that there is a very smooth structure And in case of treated cotton, there is maybe some deposition of either maybe phosphorus, either maybe BTCA. And in case of plasma treated cotton, we have seen that there is a little bit of surface roughness and the phosphorus moiety spread evenly over the surface of the cotton. We have done the thermogravimetric analysis to study the thermal stability of the cotton. From here we can see the continuous line is for virgin cotton. From here we can see that the thermal degradation started around 350 degrees Celsius and it decreasing sharply, and around 450 degrees Celsius the weight already 80% of the 80% is destroyed and 20% only remaining, and the 95% is destroyed along this 500 degrees Celsius. And in case of virgin treated cotton and plasma treated cotton, we can see here that their thermal degradation around 350 degrees Celsius, there is only 40% degradation is there, and 95% degradation is around 750 degrees Celsius, which means this treated cotton is thermally stable. We have done some FTIR studies also for cotton samples. For blue one is virgin cotton, green one is cotton plus FR only, and the pink one is treated cotton. We can see that the peaks is there 3300 centimeter inverse wavelength. For the three cotton fabric, there is the same peak is there. This peak indicates the wedge group, and 2800 centimeter inverse we can also see that for the three fabric there is also 2800 inverse wavelength, indicating the CH stretching group. And in case of 1720, we can see that this peak is only present in cotton plus FR and treated cotton. This group is not present in the virgin cotton. This group is indicating C11O, and 1780 there is a group. This is specially for carbonyl C11O group, which is also present in cotton plus FR and treated cotton, and which indicates that esterification reaction was happened there. And we have done the washing Landau cycle also. We have studied the washing durability. Up to 5 hours it gives 28 around, and we are trying to improving it, and the study is under process. Thank you.
So first of all, Shreyashi, sorry I did not introduce you initially for the benefit of the audience. Shreyashi is presently working as Senior Scientific Officer in BITRA since August 2022. She received her Master's degree in Textile Technology from Calcutta University and Bachelor's degree from Government College of Engineering and Textile Technology at Serampore. She is presently pursuing her PhD as well. Apart from being a Senior Scientific Officer at BITRA, she is also heading the Physical Test Laboratory and taking additional responsibility as Technical Staff Officer of the Director. Before joining at BITRA, she was an Assistant Manager at Raymond, Hane, where she was responsible for quality assurance and technical services. Her present work involves flame retardant fabrics. Right?
Thank you.
Before I have a question for you, Shreyashi, I would like to ask the audience, anybody in the audience who has any question for Shreyashi? All right. Shreyashi, since you're working on coated cotton, my question for you is that have you checked the toxic gas emissions?
Just, it is under process. Still not. We will do it later.
Okay. So it's yet to be checked?
This is initially, yes. We will do it.
Okay.
Yes.
And the second thing is that we know that cotton is a natural fiber.
Yeah.
So when we do treatments on cotton, we find that the physical properties of cotton degrade. To simply put it, there's a reduction of almost 20-25% in tensile and tear properties. So when you're doing the treatment which you are following, have you
Yes.
been able to bring out a comparison?
Yes, there is no such significant loss in tear or tensile strength, but there is a slight reduction of yellowness property.
A slight reduction in
Yellowness properties of
Yellowness
the cotton fabric, but it is negligible.
All right. So I wish you success in your project forward.
Yes,
And
sir.
also we are
Yeah,
looking
thank
forward
you,
to a
sir.
paper being published on a bigger front once you get
Yeah.
success in this area.
Yes, thank you very much.
Thank you so much,
sir.
Shreya.
Yes.
Thank you so much. Moving forward from coated cotton, I now invite Dr. Parmar. He is going to be talking to us about development of extreme cold climate clothing using a natural fiber, which our minister has also spoken to us about in the morning. If I have to introduce Dr. Parmar, I actually don't know that I need to introduce him at all in this, gathering. But just a few words for him. He has been working in NITRA for the last 30 years in various capacities, whether it be as an advisor, a director, a leader, a mentor, a lab technician, a go-to man where NITRA is concerned. Dr. Parmar has published 135 articles in various national and international journals, worked on numerous projects, guided 48 projects at PhD, MSc and BTech levels. He has also presented 140 papers in various seminars and conferences. He successfully has completed 28 R&D projects which were funded by the Ministry of Textiles and the Government of India and NITRA. He submitted several project reports to the Government of India for funding and filed 9 patents in India. He has also been granted 3 patents. He has authored and co-authored 17 books which include denim, garment processing, etc. and has also received 2 times the Best Technical Book awardee from AICTE. He has also received 2 Best Research Awards for his works in denim and development of low-cost sizing machine respectively. He was awarded the Honorary FTA by the Textile Association of India in the year 2022-2023. He is chairman of the BIS Sectional Committee TXT 38, Textile for Mobile Tech Application, and also a member of various BIS sectional committees. Apart from being involved in various consultancy and training programs, he has framed many qualitative requirements, especially for the Defense Services and the Ministry of Home Affairs and the paramilitary forces. With such a long list of accolades, I'm sure Dr. Parmar, what you're going to talk to us about is already a reality and is going to be on a wider front. So I leave the floor open to you, Dr. Parmar.
Thank you very much, sir. Just I am going to start my presentation, and you can see over here, actually development of extreme cold climate clothing using a special type of natural fiber or which is having a very high flow value. And this is a new fiber we have identified. I should not say new fiber, I am working on that fiber last 15 years, and now I am going to present something about what we have achieved in this fiber. And also we would like to mention that the fiber is now available with us. We are cultivating it over here. Means the supply chain, otherwise there is always problem with supply chain. So we try to fill that also, that gap also, and now we have started cultivating this crop over here in NITRA land, and we have first 2 acres of land we have cultivated, and we have used that fiber for making various types of product out of that, which we are going to discuss over here. So this is the topic of my presentation, and my team is there, Dr. Preeti, Dr. Nidhi, they are my team. And before starting actual product development, I would like to introduce something about extreme cold climate clothing, what type of clothing they require, and how you can correlate different types of fiber material with developing these types of special material. So we should know what is extreme cold climate. Sometimes we say that the temperature below zero, we call it extreme cold climate. And we also define it that if the altitude is ranging from 9,000 feet to 23,000 feet, yeah, we call, and temperature may fall of -40 and sometimes -50 degrees Celsius depending upon air velocity also. So that comes under that extreme cold climate atmosphere. And there are various types of problems you can feel if there is an extreme cold climate. One is that wind chill. As its name indicate, wind means air and chill means cold. If the air is flowing very high speed and there is a cold climate also, that the wearer of any clothing, they may feel that temperature is very less. So that I will explain in my next slide. These are some problems you may face if the temperature is below 0 degree. There are various types of problems like hypothermia is there. If the temperature is below 35 degrees Celsius, then you will feel this type of problem. Frostbite is also there, that fingers, toes, nose, ears, cheeks and chin. You will feel that type of color, which we have shown over here, that it will become blue sometime. And if you see the right side of figure, you will see that the healthy person should have a temperature, inner temperature 36 to 37 degrees Celsius. If the temperature starts falling, so it becomes shivering, and if the temperature fall of that internal body temperature fall 32 to 35, that we call it core temperature. Core temperature fall up to 32 to 35 degrees centigrade, you may feel that the cold is there, and it go below 28 to 32, that sometime you start that you are going to be unconscious. And if it fall more 24 to 28, you will unconscious, and around 24 degree or lower than 24 degree, there is no sign of life. So this is the effect of cold temperature on a human body. These are the various types of effect you can get if the temperature is very low. Immersion trench foot is a medical condition caused by prolonged exposure of the feet to damp or ancestry and cold conditions. Chill brain is also that you can feel the pain on your fingers and the toes. So these are some problems you can face whenever these types of extreme cold climate weather is there. This is the figure that I want to show you over here, that if the temperature, cooled ambient temperature is there, but the core temperature remain 37 degree. If the core temperature start falling, then it is a serious thing. So we have to maintain that core temperature 37 degrees Celsius. That is very, very important. And in the cold season also, you can see that the body part, other body part, you can have a 32 degree on arms and 31 degrees on legs. And so these are in cold condition, but in the case of warm condition, the temperature, if the 37 degree core temperature remain approximately in the whole body. So we have to maintain core temperature 37 degrees centigrade if we want to live. This is just one comparison we are showing here. What is the difference between hot and cold environment over here? You can know one important thing is that if the temperature is rising, hot condition, in this moment I am just talking about hot condition. Left side you can see, if the temperature is 45 degrees Celsius, then we will start feeling that there is something is hot, or that we will feel the sensation of pain. And if it reaches up to 72 degrees Celsius, then our skin will completely burn. This is about hot temperature. On the other hand, if you go through the right side, if the body temperature fall below 35 degree, means the core temperature 35 degree, if we consider, if we fall below 35 degrees Celsius, then you will have these types of problems which we have mentioned over there. So this is the comparison between hot and cold climate conditions. That table I want to just show you over here. You can see that if the actual temperature 10 degrees Celsius is shown in red, and air is blowing 2 meters per second of speed, you will actually feel the temperature 9 degree. But the if the air speed increases and it reaches to 18 meters per second, that temperature which was actually 10 degree, you will feel 5 degrees Celsius. So this is the effect in cold condition. So air is play a very, very important role during the extreme cold climate conditions. So we have to have such type of clothing system that can prevent us the air velocity also. So whenever we design, so we have to consider that thing also. The extreme cold clothing, what are the role, what type of material we have to use, that it is mentioned over here. The extreme cold weather clothing refer to a clothing of Arctic or mountainous area. Its primary function is to trap air, because the trapping of air is very, very important, because it creates a pocket of you can say thermal resistance material, like a thermal resistance or insulation. So that is very important. And secondary and necessary, it to conduct water vapor away from the body. Means the water vapor permeability should be good, because if you are sweating, so sweat should not, you can say in the cold condition, what will happen, it will become just like a ice, and it will also create a problem to the body. So the sweat should pass through that garment or that fabric. That's why it is very important in extreme cold climate. Outer layer should be windproof. I have already mentioned that air-proof clothing is a requirement of extreme cold climate clothing. So the windproof sheet should be used while designing that type of clothing system. The very nice example are shown over here. This is how a polar bear adapts to the environment. You can see the polar bear. It has a various types of skin. You can see in the right side that it has a hollow transparent hair first. So when they take on water when swimming, acting like a wetsuit, also directs UV light down to the black skin. Below that, they are having black skin. Black skin absorbs heat, so it retains heat also. It has a white woolly fur that traps heat close to the body. It has a dark skin that I have mentioned earlier, the black skin, and it maximizes the absorption of solar radiation. And it has a 11 centimeter fat layer, and that insulate bear from low temperature. So these are the very important facts if you see in the bear. And here also mentioned over here, it has a greasy coat that shed water after swimming. Means the water repellency is there, already there in that suit. A small surface area to volume, that is the requirement for cold weather clothing. That it should have smaller area to volume to minimize the heat loss. You know that whenever there is a cold whatever, we try to reduce the area. So that is the requirement of this, and this figure shows that how to develop various types of extreme cold climate clothing. Here, why we require the insulation? You know that if you are having hot area and cold area, generally what happens that the heat is transferred from hot to cold area. So if we want to prevent that heat, what we require? We require some thermal insulation type of material. So that is requirement of any clothing system to reduce transfer of heat energy between two objects of different temperature. That is a requirement. That is a mechanism conserving heat energy within an object, maintaining its temperature at a constant. The thermal layer should maintain the temperature almost same. It will not work as it will not create heat, but it prevents to pass the heat from one object to the other object. That is a requirement. And of course, if you are having a various layers of clothing, what will happen? It will create poor breathability also. So we have to design such type of clothing system that can also provide breathability. This is just one diagram I am showing you how what type of flow value required, and some correlation is also given over here that if you increase the number of clothing system, you will get the high flow value. It will go up to 3.5 or more also. This is just one table I have shown over here. So somebody may ask, what is flow? Just I am explaining over here. If the flow value 0, it corresponds to a naked person. in the temperature 21 degrees Celsius and air movement is 0.1 meter per second and the relative humidity remain over there 50%. So we can say that it has a Clo value 0. But if you want to say that Clo value 1, it means that a person wearing a business suit, which I have shown in the figure, and the temperature 21 degree, air speed 1.1 and humidity less than 50%. Then we can say that it is a Clo value 1 if it is comfortable over here. Similarly, if they are 2.5, then a person wearing a cold weather clothing. And this is the relationship between Clo and TOG value we have given over here, just for understanding purpose only. Some facts I would like to mention over here, that bodies lose heat 25% times quicker in water than in air. That's why we require water repellency also in these types of clothing system. So 25% of heat you will lose quicker in the case of if you are in a water. So we must have that type of clothing system which are water repellent in nature. That is the requirement. Similarly, in the case of air flowing also, air flowing against the skin can also steal heat from the body. This is why many insulated jackets also incorporate windproof jacket or windproof outer layer. So these are the two facts we must know when we are going to design any type of clothing system. Some more facts given over here. Sweating cools the skin if it gets overheated. But in extremely cold condition, cold sweat will stick to your body, causing excessive cooling. Means we must have that type of clothing system that is having, you can say, water vapor permeability, good water vapor permeability. If you are sweating, then sweat should pass through the garment. It go outside. If it remain stick to your body, it may create problem. So that is also there. Secondly, the heat generated by the body during intensive exercise is exercise is lost to the atmosphere through radiation, because due to radiation heat will go in the atmosphere and you will feel cool. So that's why we have to preserve that heat also if we are in a high altitude area. So this is the one picture I am showing you over here, the relationship between Clo value and ambient temperature. If the temperature is minus 40 degrees centigrade, if you see the extremely left on your side, the minus 40 degrees Celsius, if person is in resting condition or sleeping, so he require Clo value 8 or more than 8. If he is doing some work that is very light work, then he requires 6 to 8. If he is doing some work, light work, same temperature minus 40, then they require the Clo value 4 to 6. And if he is just doing very hard work, then Clo value 1 will be sufficient. 1 to 2 will be sufficient. So in this way you can go further. You can see in 0 degree also, similar way you can get that if 0 degree Celsius, what temperature, if the person is on resting condition, that they require around 4 Clo value. And similarly, if he is doing very hard work, then they require 0.5 to 1 Clo value of thermal value only. So this is a very excellent curve showing the relationship between the Clo value as well as ambient temperature. So what we require a wind resistance material for developing any such type of extreme cold climate weather clothing. It should have a water resistance property. It should have a evaporative resistance material, and of course the most important thing is thermal insulation material. So these 4 minimum requirement are for making any extreme cold climate clothing. So the different types of clothing systems are available: gloves, socks, sleeping bags, boots, and some of the cases we have mentioned the requirement also. In the case of sleeping bag, the defense required that Clo value should be minimum 5, and jacket they want that Clo value should be minimum 3.5. So thermal insulation is one of the most important layers to protect the user from the extreme cold climate clothing. And mostly it can be expressed in CLO as well as TOG also. Depends on fiber fineness. If the fiber is fine and hollow in nature, then you will get more thermal value. That is the characteristics of any fiber. Fineness provides higher surface to volume ratio, resulting in numerous small gaps or spaces for immobile air. This will limit conduction and convection heat losses and thus higher insulation. So these are the important requirements, that fiber should be fine and fiber should be hollow. So if you are having that type of fiber, it will give you good results. What is being used nowadays? Mostly goose down is very popular. It has a hollow structure, it is a lighter in nature, fine, but the problem is that it is not environment friendly, and some time now it is being banned also in some nature. Polyester hollow fiber is also popular. It is not sustainable in nature, and so this is the problem with the polyester fiber. So what we have done, that we have developed one, we have investigated, and we could able to get one special type of fiber, and we have identified that fiber. It is a weed in nature, weed fiber, and it has a very high CLO value. Basically, what we have tried, that only 6 mm of layer of this fiber, only or 50 grams GSM of weight, and the total length and width, if we see that the 30 centimeter by 30 centimeter of piece we have taken for testing this value, we found that its value is 5.5 CLO. It is very high CLO value you are getting, only 5 mm of layer of that one. So this is the property of this fiber. This is the fiber structure. You can see that it is a completely hollow. 30% you can see, 20 to 30% hollow fiber it is, and its density is very low, 0.8 only. So that's why it is a very light fiber, and it is very useful for thermal. If somebody is nowadays, people are using hollow polyester fiber or various types of polyester fiber. It is heavier. For soldier, if they are using this fiber, the weight of the material will be reduced drastically. So this is the fiber characteristics, and the fineness, fiber is very fine also. So what we have done, this is some chemical properties. Cellulose is 50%, 55%. Hemicellulose there, lignin is there. Moisture again is 11 to 12% if we test the moisture again property. Hollowness I have already mentioned over here. Tenacity is there. Fiber length 28 to 30 mm. Fineness 2.5 to 3. So this is the fiber one. So what we have done, that's just, I will take a few minutes more. I am just taking that polyester goose down weed. We have compared this one. The low density, yes. In the case of weed fiber, you can see weed and goose down are almost same density over here, while the polyester is 1.3, heavier than these two. Hollowness, all three are having. High thermal value, all are three are having. Indigenous, yes. Milkweed is an indigenous one. Hollow polyester is still being imported from various countries. Low cost, weed fiber cost is, we have not determined, because we have started cultivation and we will calculate all the things, then we could able to say something about that. Environment friendly, yes, only weed fiber is environment friendly because it is a sustainable fiber. So these are some property you can see over here. In the structure, in this figure, in the horizontal portion, you can see that first we have taken the 100% weed fiber. You will get the CLO value 6.2831 and thickness 9.8, GSM 260. In the different blends of weed and polyester we have made. Left side 100% weed and extreme right side 100% polyester we have taken. You can see the different, and we have tried to maintain almost similar thickness, 9.2 to 9.8, and GSM, that is the mass of the fabric, approximately 250 around we have taken. And you can see that we are getting almost double thermal value in the case of weed fiber, 100% weed, 6.2, while in the polyester 3.3. So almost double value you are getting in the case of this fiber. This is the important thing over here. And we have made various types of non-woven fabric out of that, and we have tested again, and this is just graphically we have shown over here how if you increase, same thing are shown over here in graphically also. If the 100% weed is there, you will get the more than 6 kilo value. If you are having a 100% polyester, you will get a 3.3, around 3.3 kilo value. So this is the compression recovery. That is also very important property in the case of making sleeping bag or jacket and something else, because if the fiber compressed after use, it will lose its thermal property. So that's why it is a requirement that it should maintain more than 90% of compressibility. So we have tested all the fiber, they are having a 90%, more than 90% compressibility. These are the some product which I have made. These are the weed fiber, non-woven fabric. We have made comforter or quilt. We have made this jacket. We are very happy to say that today Minister Sir has having this type of jacket. That jacket was provided by NITRA only. And these are the garment we have made out of that. This is the khadi half jacket we have made. Its flow value is 1.5. And we have developed that comforter. It has a 30% of weed and 70% of polyester fabric. Its flow value is 4.5 and only a 1 kg of weight. Total weight is 1 kg. And if we use that one up to minus 30 degree, we will feel comfort. We have made that type of product also. We have made this jacket. You can see these products are shown over here in our stall also. This jacket we have made, it has a flow value 2.5, weight around 664 grams, GSM 200 GSM, minus 20 degree you can go up to minus 20 degrees Celsius. So this is single jacket we have made. In the case of defense, there are 2 jackets they are using, outer and inner. That's why they are getting 3.5 kilo. But in our case, our jacket weight is less, and we have used only 30% of weed fiber. If we increase that weed fiber percentage, 40%, this single jacket will cover all the property. This is also sleeping bag. 2 types of sleeping bag were developed. One is having 200 GSM non-woven fabric we have used, and weight is, this one is 1135, and it go up to minus 20 degrees Celsius. In other one, 400 gram GSM, 2 layers of 200 gram we have used, and it go up to minus 50 degrees Celsius. And if we see the specification, in the case of defense specification, we have shown over here in the blue line that in paramilitary forces, they are using 200 GSM of fabric, and they want that flow value should be around 2.1, and they want that the weight should not be more than 1150. But in our case, if you see that in green, 1135 gram only, weight is less, but it will go up to minus 20 degrees Celsius. Means if we further reduce the percentage of weed, you will achieve that one also. And similarly in the defense also, the weight is around 2 kg, you can say 1980 grams, while in our case we are getting 1626. It is very lighter compared to that one. So this is the another achievement with this fiber. So I am thankful very much, and this is a part of NTTM projects, and they have funded us, and I am also thankful to my industrial partner, that Arvind Limited and Rednick Export. They were with us during the development. Thank you very much, sir.
Thank you, Dr. Parmar, for that exhaustive short time explanation from usage to product and its various categories. First, I would like to ask the floor if anyone has got any questions from the floor or the audience. Okay. Dr. Parmar, since I've been involved with a lot of research and development for the defense, I have few small questions for you.
Yes, sir.
So, when we are designing a cold weather clothing, especially to be used in the Siachen area, one of the important characteristics is the moisture or the water retention of the wadding which is used.
Yes, sir.
Here, when we are using a combination of polyester and wheat, has there been any study done on the moisture retention capability?
Yes, sir.
If it gets wet?
Yes, sir. I just want to explain one thing that is very, very important in this fiber, that this fiber is hydrophobic in nature. Although I have shown you that its moisture again is 12 to 13%, but basically it is a hydrophobic in nature if it is not treated well. So that's why this fiber is very useful in the case of oil absorption also. We are working on that project also. If we put that fiber, if the mix oil and water in a glass or in a beaker and put this fiber, what will happen? It will absorb all air. It will not touch anything of water. It will absorb air, oil only. So it is a hydrophobic in nature. That's why the moisture will not affect this fiber. Second thing is that if you make it, wash it or scour it like cotton, its moisture again improve dramatically, very high. So that is the points just I would like to
Understood. My second question to you is that how fine in terms of the GSM and the denier of the fiber have you been able to develop? Because where the jackets for the Siachen soldiers and the sleeping bags are concerned, those are immobile application products. But you have got active products which are being used by people in the field in those areas, starting from minus 15 to minus 40 degrees.
Yes, sir.
So how thin can you go, how low can you go on the GSM of the product?
At this moment, sir, we could able to reduce GSM around 20% or so.
That means 150 GSM?
150 GSM we can easily go. We have made even 100 GSM batting, we have made 150 GSM, we have made 200 GSM and 250 GSM. We have made that batting also. We have done some comparative study also on that one.
Okay. And my last question is that the world over, everyone is going towards warmth without bulk. Right? In your presentation, we saw you standardize it to about 9 mm height, loft height of 9 mm for the insulation. Can the loft be decreased without decreasing the GSM?
Yes, it can be. It depends on, sir,
method of manufacturing.
Method of manufacturing. Because in our case, first we have made without simple, we have passed that one in the machine without any needle punching. Simple, you can say web we have taken. But in the second one, we have done needle punching, but it is a very slight needle punching, only just surface needle punching.
Right.
So it will hold the, you don't require any scream for that. Without scream, you can use that one. So that's we have done, sir.
Understood. Thank you so much, Dr. Parmar. We are looking forward to this being a breakthrough as a made in India Atmanirbhar product emanating right here from Nitra Ghaziabad. Thank you so much. We move to the third discussion and paper presentation for the afternoon of this session. I would like to invite Mr. Shashikant Patil to kindly address. A little brief about Mr. Shashikant Patil. He's an MTech in Nanoscience and Technology, Bachelor's of Engineering in Mechanical Engineering. He has 8 years of experience in manufacturing sector in various departments like research and development, production, and quality assurance. He is currently working as in charge and technical manager in composites testing laboratory at Atira, Ahmedabad. And from the past 2 years, he is heading the composite testing facility at Atira as well. He has previously worked at Shapoorji Pallonji and Company and Co. Limited in new product development and also in the R&D section.
Hello.
A very warm welcome to you, Mr. Patil.
Thank you, sir.
Just one sec, Mr. Patil. His topic of discussion for today with us is going to be the behavioral mechanism of composites under high radiant heat and the effect of high energy on these components, on this composites.
Yes. Good afternoon, everyone. My topic is understanding the behavior of composite materials under the exposure of high energy radiant energy flux. On here.
Downward.
Composites is basically a potential material which is being in demand all over the world in developed and developing nations. The reason being is because of scarcity of conventional materials, there is a huge demand of non-conventional and engineered materials, and composite material is a promising solution for that. Basically, composite is nothing but the combination of 2 or 3 materials which comes together and give us a better property which is required for the different applications. Because of as it is an engineered material, it can be engineered. This material finds application in aerospace industries, mass transport, building and constructions, and many sectors. And as we know, composite is having a very good strength to weight ratio. It is mechanically very suitable for different applications in mass transport and aerospace or automotives. But the one crucial parameter which needs to focus is about this material is fire safety, and my study is based on the fire retardancy of composites material. Basically what happens ki the fire retardancy parameter is evaluated using different testing standards and testing methods. But as a solution provider to automotive industry and mass transport systems, we are more focused on stringent standards and methods for testing the equipment for fire retardancy. Basically, my study is based on understanding the behavior of composite material in case it is subjected to a normal gas burner fire and a higher energy radiant flux, because there is a concept that if the material falls under the fire retardancy V0 classification, that means it is a safer material. But in case of mass transport system, this only to develop a material having a V0 classification is not enough. We have to be more stringent on our formulation, and that we have studied using our testing facility. What we have done is we have used a dual cone calorimeter for testing of hand layup FRP composites. Using these samples, using this experimental setup, we can we can know how much energy is generated by the material when it is exposed to high energy radiant flux. This instrument can develop the radiant energy of around 0 to 100 kilowatt per meter square, and we have tested some of the composite materials made of hand layup process using 50 kilowatt per meter square energy. Now, when we this is an experimental setup which we have used for this kind of experiment. What we have done is we have kept the resin to fiber ratio constant, we have kept the specimen sizes constant, we have kept the thickness constant, the flux which was exposed on the specimen surfaces was constant. Only the thing varying is the additives which we call as a fire retardant additives. we have varied the concentration of that additives. The reason is we need to understand how the material is behaving in case of this kind of high energy exposure. So what we observed was when a glass reinforced plastic sample having a 2% fire retardant additives, we tested a normal fire retardancy test method, we get a V0 classification. But heat release rate out of that material using dual cone calorimeter is observed as 112.50 kilowatt per meter square. And if we go for mass transport systems, the requirement is below 60. That means if we say the material is fire retardant as per the normal UL 94 standard, but still it is not suitable for railway applications. So what should be the solution for that? We tried on different samples and we added more and more fillers, and we tried to evaluate what is the difference coming out of it. Still, when we went to a 5% of filler content, still we were not able to achieve below 60 value in heat release rate, and also the ignition time was also not that much to extent. So we conducted another type of experiment where instead of increasing the filler content, because if we increase the filler content more, it may cause damage to our mechanical properties of material. That's why we use the gel coated samples. The combination resin matrix combination is similar, just we have added a gel coat on the surface of material. Just we have added the gel coat on surface of material, and heat flux was also kept constant. So what we observed was, if we add a gel coat sample with a 0.5% of fire suppressant agent in gel coats and same 2% fire retardant fillers, the heat release rate drastically changes to 68.20 kilowatt per meter square. Also, a time to ignition was increased to 38 seconds. Similarly, when we go with increasing the suppressing agent, the value of heat release rate goes down, and we can achieve the required value, which is less than 60 as per mass transport systems, and which is known as a safest material in case of mass transport system. So why this happens? As gel coat is consisting of a suppressant agent, when exposed to a high energy radiant flux, the suppressant creates a foam-like barrier layer on the surface of the material, like this. So if you can see, this is the sample before the test, sample after the test. A foam-like barrier is developed at the upper surface of sample. Because of it, the fire or the heat energy is unable to penetrate easily into the actual sample, because of which the time to ignition increases drastically, and as the time to ignition increases, the result being is that material is more thermally stable and it is more able to withstand the high energy radiant flux. So that we have tested, and so basically what our intention was to develop a material which is according to the more stringent standard ISO 5660 for mass transport systems, so that the process is similar which is used in most of the railway components. But the problem was the material matches the basic standards of fire retardancy, but it is not matching the heat release rate or the stringent standards. So the intention was to develop and to understand what happens to the material when it is exposed to a very high energy radiant flux, and why these kind of stringent standards are required for safety of the passengers and for protection of our mass transport systems. So that is the conclusion. Thank you so much for hearing me.
Thank you, Shashikanji, but I have one or two questions from you. Only if there's nobody else in the audience with any questions. Anybody in the audience with any question, please? Okay. Padal Sahab, I just wanted to know that the fire retardant chemicals that you've used for treatment in the composites, have they been checked for their toxic emissions?
Yes, sir. Actually, in this mass transport system, there are 4 things to be tested. First is heat release rate, how much heat is generated. Second is how much smoke is generated. Third is how much toxic elements are released from this kind of material. And fourth is how much the fire spreads in this type of material. So these 4 categories we have to check. This was the initial test which we conducted just to know the performance of material in fire, in case of fire. Toxicity is also checked of this material and it comes below 0.75, which is the normal requirement.
Yes, 0.75 is the normal.
Yes.
Okay. Second question is that when we are doing this treatment on the composites, is this treatment of flame retardancy permanent or is it affected by any atmospheric or other agents?
No, it is, this treatment is permanent, affected by somewhat environmental changes, but in laboratory atmosphere it is
So
permanent.
I think maybe that is one part which we may need to look into.
Sure, sir.
And lastly, what is the trade-off between the weight and the performance?
What's that?
The weight, the GSM of the different materials which
Okay.
you have taken.
Okay.
Because in composites, there is different molding and different kinds of GSMs and thicknesses for different applications.
Yes, sir.
So have you been able to do a trade-off over there? In the sense, cylinders have got a different requirement.
Yes. Basically, sir, our intention was, because we are serving to Indian Railways, our intention was to tackle the material which are used in mass transports and railways.
All right.
So their hand layup process is used for internal cabins and the compartments. So that's why we have used only the hand layup process and manufacture the material using that only.
Perfect. Thank you so much and wish you all the success in
Thank
your
you, sir.
future endeavors. Thank you so much. We now come to the last presentation for this session, and that is optimization of various layers of specialized firefighter suits done by NITRA. And the lead in this case is Mr. Swami Saran. I have personally interacted with Swami, if I may use Swami, I have the liberty to do that on various fronts. In fact, I have consulted. Anyway, for the people who are not aware, Mr. Swami Saran has been working as a junior scientific officer at NITRA for the last 27 years in various capacities. His main area of expertise is textile chemistry, protective textiles, unconventional fibers, and quality control of textiles. His academic qualification is MSc in chemistry, and he's a man who often goes into the depth of whatever he is doing, and I can vouch for that. Having said that, I leave the floor open to Mr. Swami to please give his presentation.
Hello, good afternoon to everyone. Topic of my presentation is optimization of various layers of specialized firefighter suit. And the team comprises Dr. M.S. Parmar, Dr. Nidhi Shishodia, Swami Saran, and myself, Swami Kuldeep Singh. Obviously, team led by Dr. M.S. Parmar. Now I come to the presentation here. Yeah. So the introduction, so what is the use of the optimization of the firefighter suit? Actually, there are plenty of firefighter suits are available in the market, and most of the imported are from imported from the foreign countries. So there is a need of firefighter suit that has to be made in India. So now the trend is there, made in India, make in India like this. So we are into that, and here we are doing optimizing the number of layers and the type of layers that has to be used in the specialized firefighter suit. So the area is like this, and the introduction is, as you see, know the firefighters' nature of job, how the environment they have to encounter during performing their duties. They play a pivotal role in the rescuing the property and the life of the persons, those who are entrapped in the flame. So objective is to protect both the property and themselves. Okay. So firefighter is the important PPE kit for that covers the most part of the body. Just have a look of the type of firefighter suits available in the market and that required in the duty. There is approach suit, proximity suit, and fire entry suits. Types of firefighter suit, it depends on the duty they are performing in the areas. Suppose for the proximity suit, where there is a 200 degree Fahrenheit, that is 93 degrees Celsius, has to be encountered in the during duty. So proximity approach suit is used. And proximity firefighter suit are used where there is a firefighter suit is supposed to expose to 260 degrees Celsius temperature as much as. And these firefighter suits are also used in aircraft rescue, firefighting also, these proximity suit. Now come to the fire entry suit. This suit has to be worn by the person, those who are fighters, those who are supposed to enter into the fire engulfed area to protect douse the source of the flame. And the maximum ambient temperature is around 1093 degrees Celsius. And the very short duration the person has to perform his duties, whatever he has assigned to them. It's not working. There are various standards available for the firefighter suits, EN 1486. This is especially for specialized firefighter suits, and this is suitable for the specialized firefighter suits. And also there are ISO standards are 15538. This is for firefighter suits for proximity and specialized both, as there is a level 1 and level 2s are there. And ISO 11613, IS 16890, and EN 469, NFPA 1971. These are for the approach suits and for proximity suits. So just look at the thermal properties. This is the target area. We targeted the limited flame spread, heat radiant exposures, convective heat, contact heat, and heat resistance. And the performance criteria we were measuring flaming properties, like whether flame reaches to the upper edge, if there is hole in the outer weir, no metal debris after flame time is as much less than 2 seconds and after glow. And say for this heat radiant heat, RSTI 24, we were focused on this. STI 24, STI T24 threshold contact time. If you see the EN 1486 and ISO 15538, so these are more relevant to the firefighter suit. Heat transfer index here in this, if you see, radiant heat transfer, that is greater than 120 seconds actually. And for STI greater than 21 seconds. And the contact heat greater than 15 seconds. Pointer. नहीं मैं हाईलाइट करने के लिए वो नहीं हो क्योंकि ना ये डिस्प्ले खा जाएगी इसका दिख जाएगा वाइट So come to this table, EN 1486 2007 and ISO 15538. Basically these standards found to be, and the area of our interest was EN 1486, and there are other fire methods are available, ISO 11613, IS 6890. These are for proximity suits and approach suits, EN 469, EN 15384. So background of the study, since these specialized fiber suits are not made in India, so they has to be imported for the purpose, for the use. And the characteristic of firefighter suit is that the wearer can stay engulfed in the flame for few minutes and to ensure carry out the task of closing the surface of source of the fire. So Nitra, along with this industry partner, Messrs System 5S Private Limited and Messrs Arvind, has started working on this work sponsored by NTTM, Ministry of Textiles, Government of India. So present study, we were focused on to these points. During firefighter operations, firefighter has to face high level of radiant heat. It has been seen that the most of the fabrics, those are being used in the proximity and approach suits, they only reflect 10% of the infrared radiation of wavelength, longer than 1 micrometer. Thus, so there is a high demand of the, so as to make it more relevant for the specialized suit. So fabric has to be reflect 80 to 90% of radiant heat. However, very few studies have been carried out on the effect of aluminum film lamination on various type fabrics. So hence the study aimed to determine the effect of different types of aluminum films and fabrics after lamination on radiant heat and thermal protection. So basically these two tests we were more focused on to. So this is our target for the study. Number one, as per EN 1486, the limited frame spread as per ISO 15025 procedure A, that is surface ignition. The fabric should not show any propagation, and the flame should not reach to the upper edge. No hole formation there, and no molten debris should be there. After flame time also should, and after glow time has to be less than or equal to 2 seconds. And here radiant heat transfer as per ISO 6942 at 40 kilowatt per meter square RSTA 24, we say it as RSTA 24, shall be more than 120 seconds. Heat transfer, convective heat as per EN 367 has to be greater than 21 seconds. Contact heat at 300 degrees Celsius, the threshold times will be greater than 15 seconds. And heat resistance, it should not shrink or more than 5% at 255 degrees Celsius plus minus 10 degrees Celsius. And the surface wetting should not be or less than 4. So, and for the prediction of burn injury, second degree or third degree, there are methods available in ISO 13506. This is done at 84 kilowatt per meter square. That predicts the second degree burn. So 84 kilowatt per meter square has, it represents that if the person or protective wear is exposed at 84 kilowatt per meter square, it will take 8 seconds to sustain a second degree burn. But this equipment is not available in India. So we have another equipment, TPP tester, there's passing criteria that can be verified, and the target is around 150 to 200 calorie per centimeter square at 84 kilometers square. Now we come to the various layers of the specialized firefighter suits. These comprises several layers, outer layers, middle layers, innermost layers. So outer layer is the first layer. It may be the 1 layer or 2 layer fabric, and the middle layer. This also can be single layer to multi-layer, and innermost 2. In the same way, single layer to multi-layer. Optimization of further first, third, and fifth layer. So challenge was to make it lighter. So we make it to get 120 degrees, 120 seconds radiant heat flux, and as well the reflectance of the light 80 to 90% radiant heat. So fabric was coated, aluminized with the aluminum film. Various type of woven fabrics were taken and having different GSMs. And after going through the several trials, we took the different type, having fabric different GSMs, F1, F2, F3, F4, F6, F7. And then the fabric was aluminized using the aluminum film. And you can see the weight increased in the fabric. Say for F1 365 it was earlier, after coating it got to 427. But if you see the radiant heat transfer, radiant heat index, this was 7.4 before coating, and after coating it got improved up to 106.3. And also you see the TPP value, thermal protection performance value, that predicts the second degree burn, 8.2, and it reached up to 11.5. So after going to the thorough and then compilation, we got to know ALF2 880. This was showing higher 1180. Actually, our target was 120. So we are just with this one single layer, we got this target, and also the TPP value. So after compiling all these things, we selected from this table the layers. First layer, we got this performance highlights you see there. A fabric ALF1 shows RSTI 106.3 and TPP rating it was 11.5 kilocalorie per centimeter .s, and aluminized ALF2 it is 118, and for ALF7 it is 1102, and TPP is a 15 sec. So all samples exceeds EN 1486 FR test requirements. ALF2 demonstrated superior performance, and this was selected for the outer layer based on the highest TPP and RSTI 24 values. Now we come to the third and fourth layer. From the same table, we got these fabrics suitable for the third and fifth layer. The optimization third layer material was again aluminized coated fabric treated, and the properties here you see the RSTI 24, 130, and the TPP rating is 8.2. And the aerial density is very low, 116 GSM. So justification comes here, a high radiant heat resistance and low mass, crucial for reducing overall suit weight. And the fifth layer optimization, material aluminized ALF5, radiant heat was found to be RSTI 24, 1017.9, and TPP it was 8.4 calorie per centimeter square. It was again a aerial density, it was lighter. Justification is there, offers additional heat blockage close to skin and providing enhanced protection since it is going to the fifth layer. And then the second layer and fourth layer, so we need some non-wovens like for thermal insulation and all these things. So fabrics were analyzed, non-woven fabrics with varying aerial densities sourced from the industry and aim to identify with high TPP and lower aerial density samples. And the samples were selected, NW5 was selected for the second and fourth layers, offering a balanced TPP value with lower mass compared to NW6. If you see the aerial density and the TPP value, so non-woven 5 having aerial density 485 and TPP value was 28.8. There was also for a higher value we got this 33.1, and if you see the NW4, it was having 32.3 TPP value, but the aerial density was 568. So that was not found due to its heavier weight. So all these layers, first layer, second layer, third layer, fourth layers were combined, and then layer composition was like this. Layer 1 was aluminized fabric, ALF2 for higher radiant heat protection, as it was giving the higher radiant RSTI 24 value, and also the reflectance of the radiant heat was as high as 98% around. Layer 2 and 4 non-woven, NW5 for optimal TPP with manageable weight, and layer 3 aluminized fabric L4 for further radiant heat resistance, and layer 5 was aluminized for finer heat. The performance of the overall fabric, the composite was found to be Aerial density was 2149 gram per meter square. And the RSTI 24 we achieved here 1002.2 seconds and TPP value 247.7 calorie per centimeter squared seconds. Implication that provides an estimated 123 seconds for escape before second degree burn. So basically this is a property we have to achieve and the target was achieved, significantly enhancing the wearer safety. The conclusion is there. Optimization of achievements. The study highlights a strong correlation between the fabric mass, thermal protective performance, and radiant heat resistance. Layer-specific optimization to the selection of materials that delivers high protection with controlled weight. Because the weight is the key factor here. Because if the heavier with the weight, it will be difficult to wear it and perform the duties. The superior performance of the fabric FF1, TPP value, highest value we achieved here, 247.7 calorie per centimeter square, and the total mass it was found to be 214 gram per meter square. Implications that FF1 is configurations offers maximum protection with minimized weight, crucial for firefighter safety and agility. Advantage of FF1 was found to be the multi-layer FF1 suit provides exceptional heat resistance, allowing up to 1-3 seconds before the risk of second degree burns. Lower overall suit weight improves firefighter mobility and operational efficiency. FF1 is therefore the optimal choice for extreme heat scenarios, enhancing wearer safety and performance during firefighting operations. Final note, this study demonstrated a careful material selection and layer optimization can significantly enhance the effectiveness of firefighter suits, making FF1 a benchmark for future protective clothing innovations in firefighting. So here we are thankful to the National Technical Textile Missions, Ministry of Textiles, Government of India for sponsoring a project on development of specialized firefighter suits. Under this process, this work was carried away. Thank you very much. And the last, I would like to thank you, Dr. M.S. Parmar, for giving the opportunity me to present this. Thank you, sir.
I would ask anyone from the audience if any question. Swamiji, I have one or two small questions for you. So when we did the comparison of the specialized fire suit by optimizing the various layers, did we compare it to the NFPA requirements as well?
Sir, if you see the NFPA method, NFPA 1971 is there, NFPA 2112 is there. Actually, they have two tests only in that requirement. One is the TPP, and another is the vertical flammability STMD 6413. But if you see the wide in the wide spectrum, the EN 1486 and IS 16890, they have limited flame spread, contact heat, radiant heat, all the tests are there. So to cover all those things, so we got this. Actually, they have this in one test, they have TPP test. So that predicts the second degree burn. And in case of NFPA 2112 is there, they are having EN 13506, that is a thermal mannequin test. Here, flame mannequin test is there. But that predicts the second degree and third degree, both it predicts. But we don't have facilities, so that we took this.
So going forward from that, first of all, for the benefit of the audience, as Swamiji pointed out, the thermal mannequin test, I think by March or April of next year, the test facility will be up and running in Nitra. And again, for the benefit of those who are not aware, this is the live simulation, the closest live simulation to an actual situation when a person is there in fire. So you've got a thermal mannequin with about 1800 sensors on it, which when exposed, the entire mannequin is exposed to fire from all sides and for a period of 3, 4 or 5 seconds. And what is the predictive burn injury on a person, on a human, is noted and calculated. So for the first time, I think maybe IIT has got this facility, I'm not sure. But in India, due to the grant and the aegis of the Ministry of Textiles, this test will now be available. So all end users whether it is the military, whether it is the paramilitary or other organizations, the steel workers, etc., can actually get that test done over here to predict that how much safety is being given to the wearer. That is point number one. So I think that will take care of that. Also, I wanted one more question. One question is that your final optimized layering system which you have calculated.
Yes, sir.
Right? What you said the overall GSM is about 2200.
2137.
Approximately.
Yes, sir.
2200. So does this fall in line with the NFPA and the European requirements? Because has any garment been made to see the operational efficiency?
Definitely, sir. So actually, the objective is to make it more lighter. So and without compromising the thermal properties. So we are trying to keep it as lighter as possible.
Apart from the fact that NITRA is a center of excellence for protective wear in the country, I would also recommend if we could make something and get collaborative tests done overseas for the overall ensemble, so that we can collaborate, and also because we are part of the BIS committee, how we can add this to the BIS committee to give it impetus. Because lower the weight, better the protection. That's what the end user wants.
Yes, sir.
Thank you so much, Swami.
Thank you.
So, ladies and gentlemen, we come towards the end of this session on protective textiles. We've had an exhaustive session in terms of various discussion and panel presentations by the members here. At the end of the day, whichever way we look at protective textiles, what's very, very important is to keep in mind, as I said in the starting, the end user's requirement. The heavier the set of protective textiles that he wears, the lesser is the operational mobility. While if you ask the user, the sky is the limit as far as his requirement is concerned, science progresses at its own pace. And as researchers and developers, our aim is to come as close as we can to the qualitative requirements of the end user. Keeping these thoughts in mind, I call to close this session and thank you all once again for attending this session. Thank you.
Ladies and gentlemen, we have come to the end of a very interesting session. I am sure everyone present have enjoyed the same and have gained vital inputs that would be useful to them in their professional life. May I now request Mr. Sandeep Hora to honor the speakers with a memento. Dr. M.S. Parmar. Ms. Shreyashi Nandi. Mr. Shashikant Patil. And last but not the least, Mr. Swami Sharan. Thank you, sir. May I now request Mr. Vivek Agrawal to honor the session chairman with a memento. On behalf of NITRA, I express my sincere thanks and gratitude to Mr. Sandeep Hora for sparing his valuable time from his pressing schedule for the conference and conducting the session in a lively manner, incorporating his own textile expertise and personal touch. We have been enriched by your presence, sir, and hope you have also enjoyed the session as much as we have. I also thank all the speakers for having presented their papers in a very nice and lucid manner. I am also very thankful to our esteemed audience for your active participation, making this session a vibrant, full of knowledge exchange. Tomorrow, we will assemble here again, and the first session will start at 10 a.m. So now, request all the ladies to please join everyone for the tree. All session will be conducted tomorrow here only. Thank you.